Welcome to today's session on Apache Nifi tutorial by Intellipaat. Apache Nifi or Nifi is a powerful, easy to use and reliable system to process and distribute data between different systems. Apache Nifi is a real-time data ingestion platform which can transfer and manage data transfer between different sources and destination systems. It supports a wide variety of data formats like logs, geolocation data, social feeds, etc. In this session, you will learn all about Apache Nifi. So without further wait, let's check the agenda for the session. So first we'll be learning about introduction to Apache Nifi. Then we'll be talking about Apache Nifi use cases. After that, we'll be talking about Nifi connections and processors, followed by working with attributes in FlowFile. Then we'll be knowing more about log configuration and monitoring logs. After that, we'll be doing a small hands-on on Apache Nifi. So that's all with the agenda. Now let's start the session.
But before we begin the session, make sure to subscribe to our channel and press the bell icon so that you'll never miss any update from us.
So module 1 is about very quickly going through the basics so that we are well prepared for the hands-on and taking up the next course. So this is the objective, the first module, or Nifi terminologies, more on Nifi flow files, processors connections, then processor categories. So that's where I would like to focus. I would like to share a list of processors also, wherein though of course they are around 300. I think 286, the latest version that I have, 286 different processors out there. It's not humanly possible to walk through each one of them, but some of the processors where we need to focus, I've been given a list. I'll take into consideration the list of processors important. And let me tell you guys, practically, if you see from the real world point of view, based on the use case, of course, some of the processors are more important than others, right? But in general also, so for example, when you're working on a particular use case, for you, like in this case, probably Kafka processor, probably RDS one turns out to be probably more important. But in general also, there are a couple of processors which are very important in industry. So we'll focus on that. We'll take up from both standpoint of view, from our use case, of course, and a very, very brief on some of the important processes which are important to know, so that you know like which particular processes are probably used more as compared to others in general. Types of processors, that's what I'm talking about. So processor categorization, and then the types of processors available in Nifi. I have got a list from Deloitte, so I'll just walk you through that list quickly. Connection configuration. Now we'll talk about how different configurations look like in the connections, like what we can do about different configurations in the connection. Processor configuration similarly. So we have got 4 tabs there, excluding comments. We'll talk about processor configuration settings. We are talking about processor configuration scheduling, and we are also talking about processor configuration properties out there. So these are 3 different tabs for any processor, and we'll get into depth of those different options out there, what exactly they are and how we can make use of them, how we can play around with them, and how do they exactly affect my process. And then what are the relationship in Nifi processor relationship, failure, success, how do we handle them, how do we terminate them, right? All those things. And then very important, which is about the queuing and back pressure in Nifi. So in connectors, I'm sure you must be knowing about it. So how do we handle the back pressure? So like it usually happens, the source and the destinations, one of them is faster than the other. Let's say the source is producing a lot of data which the destination is not able to take it up. Then it goes through the buffer, or what we call it as connector, and how connector can be configured so that we can handle the back pressure out there, right? Back pressure in rough terms is buffering the data out there, and how does it actually help us do the job? Okay, so quickly we'll go through this session, this particular module, as I told you. Very quickly, very, very brief, very open source distribution. It's getting really, really popular, guys. When you talk to clients, I'm taking up, so I'm giving you some of the insights when you speak with the customers who, so the customer doesn't have, let's say, any idea about Nifi. And trust me, I've seen it many times when you discuss with them that this is the capability that you have, this is the flexibility you have. Trust me, they are left amazed. Okay, this is the power Apache Nifi brings to the table. So it's an open source data distribution. It can start off with very simple workflows, and it can get really complex. So and all with clicks that I'm sure all of you know. All few clicks here and there, and you can create a very complex data. We'll see them hands-on. Provides a way to move data from one system place to another system or place. So that's where the power lies. So you can, with few clicks, drag and drop here and there processors, connectors, and make a very good data. And that's where its power really lies. The time it takes for you to develop the flows is very less as compared to traditional way you will probably design those. Making transformations, routing decisions, like some of the ETL part we're talking about. So it's not just about moving the data from one system to another. It's also about processing the data as it flows through. It's also about doing ETL on it. It's also about routing the data, making the decisions. So if let's say a simple example, if a file is coming from a specific source, then I'll route it to that processor. If it is coming from this specific source, I'll route it to another processor, right? All those things we can do here, and that's where the expression language comes into, and that's really handy. Okay, we'll get into in depth into that. We'll see a lot of hands-on around scalable directed graphs for data routing, transformation, and system mediation logic. So this is where the capability, the expression language actually gives you the power to do the last bullet point here. Okay, so we'll discuss about that. So please understand, it's not about just moving the data. It's also about doing a lot of processing in flight, like real time on the data. And with all these things come into picture, you can assume fault tolerance, availability, scalability, all those things are default here. We'll of course talk about them. So we are bringing in data from different sources. We are also doing a lot of data routing, transformation, system mediation logic, and then putting in data to the destination. And all that with clicks. Okay, all that with clicks. Now, very quickly, so this is where it is. Some use cases, okay, not of course, it is just a gist of it, and maybe a recap for you. But I would like to do it because I want that we are on the same page and everybody understands from ground zero. So I'm being very quick. Automation of flow of data between systems. So like from JSON to databases, from FTP to Hadoop, Kafka to Elasticsearch. So from one system to another. So some of the use cases very popular in the industry I've just mentioned. Data could be anything. It could be log files, it could be HTTP request, it could be XML, could be CSV, audio, video, telemetry data, could be anything. Telemetry data, for those who are unaware, it is the data which is getting generated at the source, and you want it to be transferred to the destination very quickly the moment it gets generated, like IoT, right? So these kind of use cases. Apache Nifi is turning out to be really popular in IoT use cases, guys. So that's the future use cases. Drag and drop interface, focus on configuration of processors. So you do what exactly you should be focusing on, and you delegate the behind the scene processing to Apache Nifi. So the heavy lifting is done by Nifi. You simply drag and drop, make connections, create those flows, and behind the scene, Apache Nifi actually does the processing. It of course does DAG creation. There are ways actually it processes. It goes through. I'll touch upon that internals also as we go through in details how exactly behind the scene things work. I think that will give you a clear picture. But if you see from the 36,000 feet, what you are doing is you're playing around with the processors, connectors, schedulers, and configurations. But behind the scene, the heavy lifting Apache Nifi is doing for you. It's taking care of that. What are you trying to, the kind of flows that you are trying to create, they are getting created behind the scene, and also are processing, and also the things are working as you expect them to. So the focus is basically on the configuration of processes. This is what matters for the user, and rest everything is taken care by. Scalable across a cluster of machines, we'll see that. Okay, it's not about just standalone installation that I think you must be aware of as of today, but in real world, that doesn't work because there's a lot of data which is coming in, and you have to take care of scaling part. So we'll see how an Nifi can be scaled on a cluster of machines. Guaranteed delivery, no data loss. Guys, this is very critical. Not sure how many of you can understand the criticality of it. In some of the business use cases, data is absolutely critical. I mean, not even a single record can be lost out, right? Many use cases are there. Of course, some use cases wherein you're talking about logs, etc. Probably you can still afford to use some of the Apache server logs for that matter. But other use cases, especially in the banking sector, payment industry, right, and of course many more, you can't afford to use even a single record, even a single piece of data, and that's where it gets really critical. Again, just configuration, and you can ensure that the data which is coming into the system is guaranteed to be delivered. You can't afford data loss, and you can do in Wi-Fi. Data buffering, back pressure, prioritization, queuing, latency versus throughput, that we will see. So this is again configuration here. We can actually do the data buffering here in Apache Nifi. As I discussed, one of the source is sending data at a very, very high speed, which destination is not able to process that quickly. Then you can have this sort of concept coming into picture, the back pressure. You can prioritize the queue. We'll get into the details of that. Like you say that these are the different flow files which are coming into the system. Now, how do you want to prioritize them? Do you want to have your own prioritization logic? Even custom prioritization can also be done based on certain features. But there are 4 or 5, I think, as I do recall, it is 4 by default options given to you. For example, you can say first in, first out. The first flow file which comes into the queue should get processed. You can do vice versa. The last one should get processed first, right? And you can do different configurations as well. And again, just a configuration. Okay, you are not going to write any code for that. It's by default given to you. You just need to pick up the right option and let Nifi take care of them. Okay, so it comes, we play around with these different configurations based on the business problems. Okay, so for example, in a transactional system, when we talk about, right, usually let's say a fraud detection system, etc., what you want is you actually want the transactions to be processed as they are coming in, because what exactly happens is if you see in the fraud detection system, what happens is you play around with the pattern of the transactions coming in from a user. So what exactly happens is last 3 minutes, I want to see how many number of transactions are coming in, right? So what I want to do is I want actually the transactions to follow their natural orders. As and when they are coming in, I should be able to do the process. Okay, and then the templating. So we can create templates. These templates are nothing but they are predefined set of processors, set of configurations, set of let's say set of instructions, like you do let's say in some of the programming languages I talked about, the importing the packages. And so it helps you. You can even use somebody else's templates out there. Guys, there are tons and tons of open source templates available on the web. Somebody has done a lot of work already. Let's say some ex company guys, they have created some sort of complex flows, right? And these flows, they have actually made it available to others. They have done the templating, they have created those templates, they have made it available on the web. So there is possibility that what you are looking out, right, or maybe a piece of it at least, has already been done by somebody, and they have made it available on the web, the XML file. So if it is available, we can get it from there. We can actually import it into Apache Nifi, our system, and can start making. Okay. So this is where templating, and you can also do that. So let's say some of the business problem we are going to solve, we have created some flows, some processes, some connections, and it's working fine for us. What we can do is we can create a template of it, and we can actually make somebody and make it available for someone else to use. That's also possible. We can do somebody else's work. They were kind enough to share it with us. Okay, they have made it available on the web, or we can also do the same way. So it actually gives us a lot of power to have those templates readily available so that we can make use of them, and it helps us do the development. Perfect. Now this is an important slide, guys. This is an important slide. Very quickly, so there is some sort of confusion, or I would say not clarity in the industry. Those who have worked on Nifi for some time, they would know, but still, just for the sake of clarity, this is what Apache Nifi use case is in industry. It is good at. Now, please look at this very quickly, that the things Nifi can do. So it's good at these things, the top points, but not good at these. And we should actually force fit Nifi into the use cases mentioned below. So reliable and secure transfer of data between systems, yes, you can do. As long as it is about data transfer, you can definitely do. Delivery of data from source to analytical platforms, that's also possible. So you can get in data from, let's say, real-time streaming, like from, let's say, weblog data, you can get in from different web servers, let's say amazon.com. You can get in data from there. You can do some sort of ETL if you want to do, for example, some sort of data cleaning, filtering you can do. Let's say I don't want to process some sort of error codes if the data has got 404 or 500, though you would like to do all of them, but if you want to do that sort of filtering, you can do, and then push the data, do that bit of ETL and push the data into, let's say, some sort of analytical store. Let's say you can dump the data into HDFS. Okay, that you can do for sure. Okay, that is definitely possible. But what is definitely not possible is we'll discuss shortly, right? So and then the enrichment and the preparation of the data. So conversion between different formats, CSV to JSON, JSON to CSV, right? Or different sort of conversion. All those things, yes, very good. You can do real time. On the fly. Extraction, parsing, that's where expression language power comes into picture. Routing decision, so how do you want to route the data? Then, if, as I told you, if the data has got a specific format or coming in from a specific source, I can route it to a specific system for further processing. If not coming in from that source, I'll push it to another processing system, processors, and so on. Those routings can be done as well. Now, what Apache Nifi should be used for? It should be used for distributed computation, wherein a lot of complex distributed processing is required. Please don't use Apache Nifi. It's not meant for that. You can't force fit Apache Nifi there. I'm sure you do understand distributed computation, like Spark, if you guys know of, right? Spark does a lot of complex distributed processing. So no, it's not meant for that. Okay, there are specific tools, technologies available out there which should be used to do that. Complex event processing you can't do. So, for example, like I was talking about, like let's say the same fraud detection system we were talking about. So we are talking about complex processing there, wherein data is coming in from different systems, and real time we are doing the decision making there. So stream processing. So for example, transactions coming in, right, and the transactions coming in, and what you are trying to do is you are trying to do some sort of complex processing, like some summations of the event, some sort of aggregations you are doing, like I mentioned here. You are joining different streams, right? You're doing the joins of different streams, then doing processing on top of it. Got it, right? All those things, no, Apache Nifi is not meant for that, right? So as you scale through it, you run it on a cluster, you actually make it more and more performant. What we are talking about here is the complex event processing. We are not only talking about joins, we are also talking about the decision making on that joined stream. That's not something which Apache Nifi should be used. Are you getting my point? So as such, there is nothing which if you scale it further, more you can have running it on a cluster. You can have more and more joining capability coming into that. But what it shouldn't be doing, it shouldn't be doing the decision making on the joined stream in real time. No. So there are different systems like Storm, there is Flink, there is Spark Streaming, there is Kafka Stream, right? If you do understand, so they are the systems meant for doing this processing, which is complex event processing. Is that clear? Sid, all of you, where should we use? Is Nifi more close to ETL types of operation or real-time system? It can do ETL in real time as well, right? But if you ask me practically, right, we should use Nifi if it is a batch kind. So basic ETL you can do on Nifi. Okay, on real time also you can do ETL, as I told you. Like data is coming in from Kafka source, you can do a bit of ETL there and then push the data into the processing system, or you can probably put it in some analytical store. All that you can do. So it is used for real time system. It is used for ETL. So it means you can do real time ETL as well. But what you shouldn't be doing is that you shouldn't be actually doing complex processing on top of it. Okay? Joins, rolling windows, aggregates, operations, etc. So again, it becomes the complex stuff like joining, doing summations, doing aggregations, rolling windows. I think some of you were talking about. So what rolling window we are talking about is, so what we are talking about, guys, in terms of rolling window. So you got, let's say, 5 minutes data. You have done some sort of processing on top of it. Then you take the next 5 minutes data. Okay, do some sort of aggregations count of it. So last 5 minutes, how many transactions came in? Then you slide this window by 1 minute. Now last 5 minutes, how many transactions are there? Then you slide by 1 minute. Last 5 minutes, how many transactions are there? Right? That's a rolling window concept. Right? Like in transaction system, you do that. Usually, so you want to actually see how the pattern of the transactions are coming in, how much transactions, let's say, a particular user is doing in last 5 minutes, what is the amount last 5 minutes, then you slide the window, then again last 5 minutes, and so on. Those kind of things, no, Apache Nifi is not meant for that. They are specific systems which are doing those kind of things, but not Apache Nifi. So before I take up your questions, guys, let me tell you very clearly, Apache Nifi is good if you are looking at taking in data from different sources, various sources. So the sky is the limit, I would say, because they have added up pre-configured 286 processor already, right? And there are many more that you can create custom processors, right? It's that's also possible. So those kind of things you can use Apache Nifi for. You can make use of them. Right, you can handle the data transfer from various systems, heterogeneous system, across systems, and do some sort of basic ETL in between. But when it comes to the complex processing, different sort of these batch processing aggregates, doing some sort of rolling window operations, no, you shouldn't use Apache Nifi code. So if you do understand the data pipeline concept, in the complete data pipeline, Apache Nifi sits at the ingestion side primarily, okay, and then some sort of ETL. That's where it is used for. So let me take questions, I think, quickly. What about aggregation joins of data from multiple RDS? Yes, you can do that, Bhavesh. That is possible. But again, what kind of different only joins we're talking about, right? What about aggregation and only joins? So if you are trying to do a lot of aggregations there, I would not say that you should do Apache Nifi. What you should do is join the streams out there, taking in data from different RDS tables, and use a processing system, use a proper processing system, an analytical system to do that kind of aggregations. So you shouldn't be doing a lot of complex processing, a lot of aggregations on top of the Nifi. Using Nifi. Joining, I would suggest, yes, you should do that. You can, so for example, what you can do is you can take in data, you can do kind of filtering in one of the data coming in from a single RDS. You can also do some sort of, filtering or some sort of ETL on the other RDBS table data, and you can merge them, you can join them, and then push the data into some sort of analytical store and do further processing on top of that analytical store. Okay, so that's where we are, I think, coming into. So the 3 points that I mentioned down, right? Please don't try to get into that territory. No, they are specific responsibilities. There are specific tools to do that. So please don't do that. What else? When you say Nifi not meant for join, what would be the approach? If I get the primary event through streams and need the supplementary data from RDS, all right, it is recommended to go back and join with other tables to extract the additional data before writing to target. Yes, that's right. That should be the approach. Absolutely. And the major problem, guys, if you see in any big data analytics platform, the problems if you see from the customer's real world, major problem, Apache Nifi. Let me refocus here because I think this is where we should spend some time. The major focus of Apache Nifi is to solve the problem of having a very smooth data transfer, data ingestion, some ETL, and then putting the data into respective store from where we will do the further processing. Okay, please understand, it is not meant to do it is not meant to replace any data warehouse system that we have got. No, it is not meant for that. What it definitely helps you is to create those data pipelines, data ingestion pipelines very quickly with the help of few clicks. Okay, earlier that was really difficult to. I mean, it is not impossible. Of course, it was really difficult. Getting in data from different sources, putting them together. Like here we have the forking capability, funnel capability, all those things. People used to write code. Okay, each one of those sources, I have also worked on such use cases where each one of those sources used to be handled by a set of developers team. Trust me, it was the case. You are handling one sort of source data, you are handling another source of data, you're handling another source of data, because at the end of the day, the first thing that has to be very efficient is about how do you get the data into the system, right? So that Apache Nifi primarily solves that problem. Okay, it helps you actually bring in data very smoothly with few clicks, or already provided processors. You make use of them, bring them together, make use of their expression language, whatever the capability that it has got. So that's about ETL part. Okay, so getting in data, yes, from different processors out of the box, yes, it is good for doing some sort of ETL based on the expression language capability that it has got. Yes, you should you should make use of it. You can do that, and all that you can do in a scalable, fault tolerant manner using clustering. Beyond that, if you say yes, I want to also do big data analytics on top of this, I want to also do CEP, complex event processing, on top of this. No, it's not meant for it. You got my point, right? All of you. Do you understand? So there is division actually. So it actually helps you do the frontline job really good. Okay, very quickly and with few clicks. It actually helps you do that for sure. Okay, so don't try to replace a Redshift or probably Spark, using Nifi. Please, this is the reason I think I've put in this. All right. Okay, now let's see the terminology. Some of the things some of the terminology, some of the terms that you will keep hearing very frequently from me. And of course, as we discussed, Nifi. Now, what is FlowFile? It's the food for Apache Nifi system. So it's about the data and its definition, the metadata or the attributes for that matter, right? So this is the flow file which actually flows through the data flow that we create in Apache Nifi. So it's about the data, actual data, and it includes two elements. Primarily, it is the data itself, the content, and key value pair, the attributes, what it is. So, for example, data would have the file name, it would have the creation date, maybe UUID, whatever that it has got. So it's about attributes of this data. So you have got plain pure data and its attributes. So that's what the flow file is all about. Okay, and this flow file gets persisted to the disk after creation. This is where the fault tolerance comes into picture. There is a concept called write ahead log, right? So what actually Apache Nifi does is every flow file that comes into Apache Nifi, it does index it.
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in Big Data Analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job. Now let's continue with the session.
It does write it to a disk. Okay, so what happens is every single bit is being written. The moment you get in data, it gets written to your disk. So even if, let's say, it gets crashed, you still got data written in the disk. Okay, write ahead log means before you actually before you actually send it for further processing, you do ETL, whatever you do, you actually get your data written into the disk first. If you see other big data systems also, that's the primarily fundamental stuff that they have actually used to do the fault tolerance. So the moment data comes in, immediately write it to the disk, so that even if, let's say, it gets terminated, say, down the line, the process, ETL can't be done, you can't write it to the destination. When you start off it, you still have the data available in the disk as write ahead. So this is where the disk persistence comes into picture. So a flow file represents each object moving through the system, and for each one, Nifi keeps track of a map of key value pair attribute strings and its associated content of 0 or more. So in short, this is what flow file is. You got your data, okay, and you also got your attribute, what this data is. Okay, and that's what the flow file is. So whatever data, whatever objects that flows through your Apache Nifi data flow, that's called flow file. So that's the heart of Apache Nifi. Now let's consider. So that's the first thing I'll see. Now we got the data to be processed. Now what next? You need to have the processing unit. What those processing units are? They are called processors. Applies a set of transformations and rules to flow files and generate new flow files. So it goes through a DAG, directed acyclic graph. Okay, let me make use of a pen here. So what happens, guys? Actually, you got this data. So let's say you got a flow file here. So what you've got is a flow file, okay, and also what you have got is different set of processors here. Okay, so this processors comes into picture. Okay, now this processor does transform the data, does some sort of ETL processing. Okay, we will discuss that. Some sort of expression language commands makes use of. Now it converts into next flow file. So if it is flow file 1, okay, it becomes flow file 2, let's say, and then set of different processes you can have. You can even pass it through another flow. You can do the routing. You can have flow file 3, because all of them are doing some sort of transformation, some sort of processing, some sort of filtering, whatever you call it as, right? So this is how the flow file goes through. It has got the processes, it has got the flow files, the data, and processors actually do some sort of process and then send it to the next send it for the next process. Okay, so this is what this is how processors does. So if you see the flow down, you got data, right, and it is called a flow file the moment it gets into your Nifi. So processor 2 got the flow file 1, it gives you flow file 2 after some sort of transformations, then it gets to n number of different flow processors based on the data flow that you have. Okay? So I'm sure you do understand that. So any processor can process any flow file. Okay, we have got set of different processors, of course, and we'll discuss about them now. The connections. Okay, so in between, if you see the processors and the flow file, how do you get the data moved? You've got set of processors, you've got a chain of processors. Now how the data flows through these different flow files, different processors, sorry, and that is through connections. All right, now troubleshooting you actually do through different mechanisms out there. We'll discuss that. Sid, how do you do the troubleshooting or the error handling? Let's say the debugging for that matter. Okay, now what you've got is, so what connections are there? Now it's basically a queue. If you know the typical traditional way of transferring the data across different systems is through queuing mechanism, right? So you've got your ActiveMQ, your RabbitMQ, and even Apache Kafka also does work as queue, right? So you have got separate system, different systems, and you want to transfer data asynchronously, let's say between the two systems, to actually flow the data through the queue. Exactly same things internally. This is how actually it is. It's been created. So you've got a kind of queue between the processors, and this is how your data, your flow files go through. So from processor 1 to processor 2, the flow files go through the queues or the connections or the connectors that you have. So you can have different sort of rules here, of course, as we discussed, right? Which one should get processed first? Which one should get processed last? How do I want to prioritize them? I'll handle it. We are just touching upon the basics here. There are mechanisms out there. Back pressure is one of them. Okay. Now, so we can define back pressure to avoid overflow in the system. So you got processor 1, processor 2. Let's say a lot of data is building up here. Flow 1, flow file 2, flow file 3, flow file n. So what we are doing here is we are actually building up this back pressure. Lot of data is coming into the queue, right? And this is how actually queues do handle the data which is flowing between two different. Okay, so that's about the connectors. Okay, we are doing just 36,000 feet, very high level. I'll get into very details about each one of these things as we follow through our session. So now a very simple data flow. If you see, data comes in flow file, it gets into connectors in between two processors. Like if you see, let me just point that out. So you got processor 1, you got processor 2. So if you see, this is processor 1, this is processor 2, and here we have got the connectors between the two. So the data gets converted into flow file because that's what we call it as. Okay, that's about the objects which are flowing through the data flow, and I'm connecting these two processors. Now you see, based on some sort of routing mechanism, or I can just route it through two different processors. Now you see here. So from this processor, it gets into this and this. So there are two different processors. So I've got couple of flow files going in through here, couple of flow files, like out of three, two goes to this processor based on the ETL logic or the expression language logic that we have written, and some of the flow files go here. And then finally, you can further take in its own flow. You can further connect it to different processes, right? So a typical, very simple use case that I have explained it to you, though you are all very clear about that, but it's about just discussing the basics. Okay, now please, I think here, guys, in this I've taken it from their website only, and one important thing, the best thing to learn about any open source is where, guys? What you suggest? The best place to learn about, to discuss, or to have information about any open source is what is the source which you would recommend to anyone, or any open source for that matter? Is their official website. Their official website is the best place. Whether it's any open source, whether Apache Spark, or whether it is Kafka, or Apache Nifi for that matter. Okay, so always refer to their official documentation. So if you see, I'm using 1.11.4 Nifi version. Here we have 286 bundled processors. Now, of course, not possible to go out there and discuss about each one of them. But if you see, some sort of categorization. So this is how the categorization looks like. So you got data transformation, you got routing and mediation, you got database access, attribute extraction, and then some of the examples out there. I'm sure some of you at least must have heard about or have also worked on, I think, some of these. So if you see broadly, if you want to categorize them, they are being categorized into transformation, routing, mediation. Some of you were talking about what are the capabilities. So if you want to categorize them into these, look at this. Database access, attribute extraction. This is where the ETL comes into picture, the expression language. Okay, system interaction. So for example, if you want to execute a Python script, etc., which is lying over in your hard disk in the system, you can use this particular process. Data ingestion, so you can get the file, FTP data, HTTP, HDFS, whatnot. These are all out-of-the-box processors available to you. Sending data, you can put the file, you can put it into S3, you can put into Kafka, you can even configure email, okay, SFTP. So you can connect to an email server as well, right? That's also is possible here. But again, guys, they are not all CEP. They are not doing complex processing or a lot of aggregations and accumulation there. No, these are all simple scenarios which we discussed about getting in data, making use of ETLs, using expression language, etc., and taking it to the next level. Making use of these different set of processors and doing some sort of nominal processing and put the data into their respective next destination, the next processor, or let's say the destination. Sending data, splitting aggregation. Okay, so you can split the text, do the tokenization, split JSON, individual fields. You can split the JSON into. You can split XML. You can join them. You can merge the content, etc. Similarly, from HTTP point of view, and recently from AWS standpoint of view also, so you can actually connect, you can have processors for AWS services as well. S3, SNS, simple notification service, SQL, queuing service, all that. So this is just a tip of iceberg. Okay, no, as you see here on the screen, 286 bundled processors. So it's just about 1520 we are talking about, but it's just to give you an idea, like high level. If you want to broadly categorize them, you are categorizing them into these different categories. Okay? Now, the list of processors, I think this is where I want to actually help you understand, guys. This is the list of processors I've been given. Okay. I think you can see my screen, guys. So the list of processors given to me is this. I think some of you can help me understand if that is right expectation. I've been given these list of processors, and I am told that these are the list of processors that usually that you should cover. Okay, you should probably get into the details of these different processors. So I will actually go through each one of them as and when the need arises, so that I can make you understand what each one of them does, what are the different properties or configurations that we can play around in these different processors, and how you can make use of them. Is that fine, guys? So this is where, and please ensure that the kind of discussions that we had at the start of the session, does this list include those processors? All of them. Okay, so I think Mongo is there, and Kafka is also there, I believe. I think SFTP is there, database is there, Kafka there, right? All those things are there. So still, if there is anything which is left uncovered, please we'll discuss them. So we can always come back and add those processes into the list. But this is what, like you see here, publish Kafka. Okay, database records, all these processes are there, but it is just a list of processes that I've given you. I'm sharing it with you because that's it. This is what I've been given, this list, and I've been told that please do discuss these processes in detail. Okay, so that's what the list of processor is. Now connecting components in details. Okay, we discussed about flow files, we discussed about connectors, we discussed about processors. Now in details we'll discuss about them. In short, what all these different things that we can do. So connections, the connectors part. Now connecting two components and acts like a buffer or the queue. Okay, this is what connectors. This is what the connector is all about. Now different settings we have there. Okay, now let me I'll take you to the Nifi UI also here. Now, flow file expiration, as I was talking about. So if data is not processed in timely fashion, right, we can do expiration there. I can mention the setting there, okay, the expiration, and then the data will be automatically removed from the system. Okay, so let's say if I say expiration is 30 seconds, then data will go off. Data flow expiration. Now, expiration can be done effectively with priority. So actually, you can play around with this. Like I want to expire, let's say after 15 seconds, or I don't want to expire at all if it is 0, right? All those things we can play around with it. Let me just show you that quickly. So if you just go there, so what we are trying to discuss now is, guys, we are trying to discuss about these different components. So one is the flow file. I mean, this is a simple and a very typical data flow we're talking about. So let's not be focused on what exactly it is meant to do, but just focus on like these different components that we are doing. So this is a processor, okay, a log message processor. If you just double click on it, you get these different settings out there. Okay, so this is the processor setting we're talking about. So if you see the processor settings, and that's where I also devoted to. Now this is in processor the configurations we have. So we have got settings, we have got scheduling, we have got properties, we have got comments. Comments is for your own purpose, like if you want to probably make use of something here, want to note something like what exactly I've done here, so that somebody else who is using it later on can make use of it, whatever that you have mentioned here, like why or in what circumstances or what context you have made some changes, configuration changes that you have done in this particular processor. Now, setting, if you see here, you got couple of settings out there. So the name, ID, the bundle, these are all default from Nifi. Now penalty duration. Now this is and you see each one of these settings has got a particular name, a particular explanation here. Okay. So now the amount of time used when the processor penalizes a flow file. So this is like, let's say a particular flow file. If you want to penalize in the sense you want to process, you don't want to process that particular flow file, and you want to continue processing the other flow files, then this is the particular attribute or the setting or the configuration that you can use. I'll discuss about this in details as well. Yield duration is that processor want to yield its processing power to other processors. As you do understand, guys, when you have multiple processors running in a data flow, what will happen is each one of these processors will require processing capabilities. For example, CPUs, okay, they will share CPUs, they will have different threads. CPU has got threads, and these threads will be allocated to these different processors for processing. Now, if one of the processors or some of the processors want to yield, what does it mean? That they want to stop the processing that they are doing and want to release the resources for other processors to take up. So that you can set up here if you want to do that. So let's say some of the processors, if you want to yield it after certain time, so that the other processors can do the processing, because you are less on resources. You do have limited CPU capability. You can always play around with that. Bulletin level, what does it mean? And always, guys, this is the best practice. Always refer to these definitions as well as the NiFi guide. Okay, like you see here. Nifi wiki is the best place to have your doubts cleared. Always refer to that. That's the source of truth, I would say, Bible for any open source, whether Nifi or any open source that we talked about. Okay. So what is bulletin level? It is about, this is where it will take you to the error handling, the debugging. Some of you are talking about how would you do that. So it actually helps you do that. The bulletin level, it tells you at which level you want processor to generate the bulletins or the logs. Okay, so as and when the processing happens, processor actually logs what is happening. Even if there is an error, actually it will do the logging. Now depends on what kind of level you have set. Here you have set the warning level. What does it mean? That all the warning and above levels will be available as part of your bulletin. Okay, what does it mean? That whenever the processing happens through the processor, you will, if you go to bulletin board, I'll tell you where it is. If you go to bulletin board, you will see for that specific processor, in the bulletin board, you will get those logs, the warning as well as the error. I mean, warning and above. If you do info, then everything will be available there. What happened to the flow file, what kind of things processor did, if there's an error, why this error came in, and so on. Okay, so this is where actually you can set the bulletin level. So this actually helps you do the debugging better. Now scheduling. Now scheduling, what it does is there are different types of scheduling strategies that you have. Let me just stop this. If you see the scheduling strategy, you have got three types of scheduling strategies here. So let me just complete it and come back to you. Now, different types of scheduling strategies. Now you have created your data flows. Now, how do you actually schedule them? How, what kind of different options are available? Right? Usually, what happens is sometimes you actually want to execute then and there, but sometimes you want to schedule them also, right? Like I want to schedule my data flow at a given point in time, or I want to schedule it after every 10 seconds, or let's say 1 minute, or whatever it is, right? So what will happen is every 10 minutes, let's say if it is get file, it will start picking up data from that particular folder in the get file after every 10 seconds, right? If you do 0, then as fast as possible, at the earliest possible, it will start scheduling it. Now what you have is, here you have time driven, you have event driven, you have cron driven. Event driven is about to be it is kind of obsolete, okay, and they are and I think it has already been it is already on its way to be deprecated. So the mostly the kind of strategies, kind of scheduling that you use will be two. One is time driven and the other is cron driven. Now let's quickly discuss about time driven. Now time driven is how quickly or how at what interval you want to schedule this particular flow. So when I say run schedule 0 seconds under timer driven, then I want to do it as soon as possible, very quickly, as quickly as possible. So for example, as I was telling you, if it is get file, I want to get the data at the moment it is available in the file, immediately, right? Or if let's say I want to do 10 seconds, what would happen in that case, guys? Let's say if I do a get file as a source and some directory, the data I want to actually get in and process further, what will happen if I say run schedule 10 seconds? Runs every 10 seconds, absolutely. And similarly, you can have different configurations here. Okay, perfect. Yeah, that's right. Now, if so, that is one. You can have 1 hour. You can have any sort of configuration that you want. Now, the another one is the cron driven. The cron driven is about how do you want to, just like your Unix cron works. So you want to schedule at a specific time. So let's say every 5 minutes. Every Monday or every Monday 5 p.m. Whatever these sort of cron that you want to schedule on, that you can do. Okay, that's possible. So that is also possible. So depends on what your business use case is. So for example, a polling kind of example wherein you want to process the data. So I'll give you a typical example. Let's say if you want to do processing every hour, like in a company like Amazon, what exactly they do is they actually get the data from their different web servers, okay, around the globe at the end of the day, okay, respective end of day in the geography, or whatever that end of day is. So what they do is they actually schedule the jobs, okay, and they will schedule it like I want to get the entire logs that I've got, because the logs processing, they do a lot of stuff. Okay, I'll give you that use case quickly. I'll just brief you about that. So what exactly they will do is from their web server, they would pick up the logs every day at the end of the day. Okay, so they have the scheduled jobs out there. What the scheduled job would do, it will pick up the data from their web servers and put the data into their data store, let's say HDFS. At the end of the day, or S3 for that matter, they'll put the data into their S3 or the HDFS for further analytical processing, like whatever the kind of processing it can be. Now, what you can do here is in such kind of use cases, you can do a schedule using a cron. Let's say end of day. Okay, so I can put in the schedule that I want to run this particular job, which is nothing but getting in data, getting the log data from that specific directory at the end of the day, and put the data, transfer the data into my analytical store, or let's say, my HDFS or S3 for further processing, further analytical processing. Okay, so those kind of things, so you can bring in scheduling capability and schedule the things accordingly. Right now, concurrency, concurrent task. It is number of tasks that should be concurrent scheduled for this processor. So how many number of tasks this processor should be running? Right, in this case, one thread will be allocated here. Okay, you have got a system. Now this system has got certain threads, and these different processors in a data flow, they are all running in parallelly, guys. Now when I say concurrent task for this specific processor, I'm talking about how many number of threads, how many different tasks I want to allocate to this processor. Right, so some of the processor will have high load, some of the processor will have lower load, because what happens is, let's say for example, I've got the data, and now a lot of data is coming in, right? Let's say the ingestion data, data I'm talking about. Now, in that, I'm doing some sort of ETL, and I'm filtering out, let's say majority of the data and passing in the remaining data to the next processor. Right? What will happen in that case? The front processors will have a lot of load, right? But the later on processors which are in the next in cycle, they will have lesser load because maybe they will have less data to process. Okay, because filtering has already been done, and so on. So based on how much load you expect on a particular processor, you can define the concurrency here. Those number of tasks will be processed or will be executed for that particular process. Okay, so this is where this concurrency comes into picture. Now here the execution part, like distributed processing, we'll discuss that in the clustering. Where do you want to execute this particular processor on? All nodes in a cluster setting, it will be running on all the nodes available in the cluster. Okay? So guys, yeah, so I think, yeah, so if you see the always there is a kind of I would say there's a competition, I would say, in between the latency and the throughput. Okay, there will always be a kind of competition. So what you would like your system to do? Would you like your system to be as fast as possible with lower latency, or you want the throughput? Do you understand latency and throughput, guys? First of all, what is throughput and what is latency? So what you want to kind of a balance between the two, right? You would like your system to be either having least latency, or you would like it to be having very, very high throughput. Okay, you would have always have to balance between the two, and that's where exactly this particular configuration is all about. So what you want to say here is that, what I want is, I am actually looking out here that I have I want this particular processor to be work in a higher throughput fashion. What does it mean? That 1 second of data at a time I want to process, and then I want to 1 second of data I want to have and then process. Because what I want is, throughput will increase when you have lot of data, and then I do process it accumulatively, not together. Okay, so this particular configuration, if you see, this is for higher throughput. Now these are the controls, guys, that you have, and we will see in hands-on. These are the controls that you have. So let's say if I want my system to be designed for higher throughput, what I'll do is I'll slide it. And guys, trust me, these sort of configuration, the handles that we are having here with the single clicks, right? If you actually do the programming, right, they are very, very difficult, not that easy. These handles are not that easy to control around. Think about it. You will keep changing your code, every time, and then you understand this, right? You'll keep changing it, and then see through monitoring tools what exactly is happening, what is the throughput I'm getting. But as a system designer, you would know that you are looking out for latency, or you're looking out for throughput. So for example, let's say any system wherein the time does matter a lot. So for example, threat detection, okay, risk detection, or fraud detection, those kind of systems. What you want is, the moment you swipe your card, right, you should be able to figure out whether this particular transaction was a fraudulent or not, isn't it? Right? What you want is, the system should have least latency out there. Of course, your throughput also should be good, but the major focus is on latency, because I don't want my transaction to be having a second or 2 seconds, and then I'm getting the response out there that it is a particular fraudulent scenario or not. I want immediate result. Almost immediately, the system should be able to tell me whether it was a fraudulent transaction or not. And that's where we're talking about the latency part. What I would do in that case, I would like my system to be as fast as possible. When I say 0 millisecond latency, individual transactions, as and when transaction get received, I want it to be processed. Is that clear? Is it making sense? Right? The control between the two. Or if you want a higher throughput, you can actually slide it to the right, and you can play around with that. That I want to actually have more and more data. I want to have more and more throughput. How many number of transactions per second? What is throughput? How many transactions you want to actually process per second. But when it comes to a system where the timing is important, you can't afford to have 1 second latency, right? You want to process the data as and when it arrives. So I'm saying I want to run this particular processor for latency, lower latency. Okay. Now the properties part. Now these properties, as you would know, these properties are around specific processors. Okay. The different processors would have their own different properties out there. So for example, let's say if you have got Kafka, you will talk about the topics, you will talk about what is the batch size there. So low latency for real time, the latency should be as less as possible, and for batch processing, you should move towards the throughput side. Absolutely, you got it right. And then you play around with it. Okay, as you go as you and you can easily play around, and that is the power that Nifi gives into your hands, isn't it? Right. So it's not that you have to do the change in the code and then deploy it, create a jar and then push it into production. No, it's pretty simple, right? You can just play around with your flows, and then have this particular control in place. But the important thing is that, yes, the real-time systems where the latency is important, where the each transaction, how long it takes to process, that is important. You play around, you go towards the lower latency side, where you want batch processing, especially, you rightly mentioned, throughput. You want more transactions to be processed per second. You actually lean towards the right side of the slider. This is the
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in big data analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job. Now let's continue with the session.
High throughput. Okay. Now, the properties part, as I told you, different processors will have their own specific properties because they are specific to the controls for that specific processor. So, for example, I was talking about the Kafka. You will talk about the brokers. You will talk about the topic. You will talk about the batch size. You will talk about the compression. You will talk about probably linger milliseconds and so on. So these are the different configurations specific to that particular so let me take quickly a different processor and then explain it to you. So I'm sure you know, but just for the sake of Kafka. So like you see here, Kafka brokers, it has got the property. So here you got Kafka broker, security protocol, topics name. So all these bold ones, what they are all these bold stuff, they are mandatory. Okay, so you have to provide that configuration always. So for example, in Kafka case, publish Kafka, if you see Kafka producer case, broker is a mandatory property, security protocol is a mandatory property, topic name format, group ID, topic name, no, these are mandated ones. Okay, the bold ones are mandatory, otherwise it will complain, it will not allow you to process. Okay, so they are required. Yeah, that's right. Group ID, offset reset, key attribute, etc. So these are the required ones. The other ones are the optional ones, and of course you can add your own as well. This is a very, very good, widely used, I would say, the capability of Nifi which you can use. I'm not sure whether you are making use of it or not, but we'll see during hands-on how actually we can play around with these different properties as well. We can add our own property if we think so. Some of them which from their own perspective, what they feel is important, they have added up already. But if you think there is any specific property which is not listed out here, you can always add and put the value for this here. Okay, that can be done. By default, they will give you whatever the Kafka provides, whatever the system provides, the default property. Please understand. Okay, even in a system like Kafka, you will have a default property, right? All those default properties are given here as well. Okay, they are all given here as well. Now, based on your use case, right, what exactly the kind of configuration you want to have, you can change the configuration in any one of these predefined properties, or you can add your own property and set the value for it. And all that is with a single click. Okay, so this is important stuff. Comment, as we already discussed, that this is about putting in your own, for your own purpose or for your team's purpose, reference purpose. Why did you do that? So, for example, I'm adding up a property. Why I'm adding up? Right? I changed a particular setting. Why I'm setting that? So you would remember that. And anyways, version controlling is there, but you just for your own, reference purpose, you can always do that. All right, and now let's talk about this particular connection bit. Okay, now in the connections, which is adding up, as I was talking about, it actually is the medium to connect the two processors. Okay, so like you see here, it says from two, like from which particular processor to which particular processor I'm connecting. So it says from this processor I'm putting into this processor. Okay, relationship we'll discuss shortly. Now settings, and this is where we were discussing about that. Gautami also had a question. You can put some name. Okay, let's say I can say Kafka connection. Some sort of meaningful name should always you should always provide it. Okay, ID etc. Is coming in from Nifi. Now back pressure. Now please understand it. Very important topic. Please understand what back pressure is. Now, back pressure is about, as we discussed, always refer here. Okay, back pressure is about to how many number of objects I want to queue before the back pressure is applied. What does that mean? That your queue will have the capability to have those many number of objects in buffer. Okay, it will be able to store those many number of objects. So as more and more objects are coming in from, let's say in this case, if I get more and more objects, just a second. So what I'm doing is I'm getting in, let's say, FlowFile. Okay, I'm getting in FlowFile, like let's say generating data randomly, right, and putting data into Kafka. Okay, let me stop it. So the use case is getting in data from a file, put it into a Kafka topic. This is my publisher. Now, if you see here, configuration. Now my configuration here, back pressure, what would it be? It would be that how many number of objects can I handle coming in from my generate file. Generate file is randomly generating some sort of data. Okay, we are not interested in at the moment what kind of data it is coming in. Some data is coming in. Now how many number of flow file objects can I handle in my flow, my queue, sorry, in my connection? 10,000. This is by default. So as long as 10,000 reports are available in queue, it will not complain. It will continue to have those 10,000 reports. Okay. The moment it reaches 10,000 or more, what it will do is, can somebody tell me what would happen if I've got more than 10,000 records, let's say, in my queue? And that can happen if, let's say, your Apache Kafka is not able, Apache Kafka publisher in this case, like your producer Kafka, is not able to process it further. Let's say it's because of some reasons it's not able to do that. What would happen in that case? Anyone, if you can help me? If it breaches the 10,000 records limit, what would happen? It will stop the generating file. Yeah, it will not stop the processor. Please understand. The processor means which processor you're talking about. If you're talking about the generate file one, yes. So what it will do is it will stop it. The generate file processor will no longer be generating the files now. So it will stop the source processor. Okay, yes, you're right. So it will stop the source processor. So your ingestion would stop in that case. Okay, so that is where back pressure comes into picture. That is one way you actually takes care of load into the system. Okay, and now and guys, please understand, when you're talking about this back pressure, you should always ensure that it actually fits your purpose. Okay, so by default it is 10,000, and you can also do it size wise also. Whichever reaches first, it will actually start working. So for example, I can say 10,000 records or 1 GB, whichever actually approaches first, it will stop the generate file processor, and generate file processor won't process data anymore. Now what you need to do in that case, you have to either clear. So for example, you can clean. I'll show you that. You can clean your queue. Let's say, I mean, typical. I'm just giving an example, hypothetical example, so that I have reduced it to less than 10,000. Okay. Usually, there is no as such actually limitation. Is based on your system, so they as such no limit there, but you should always play around with the only thing that you should keep in mind is that this data gets stored. Okay, this data gets persisted. So you should always keep in mind that you have got enough capability in the system, and usually you play around with the size threshold. So here we have got 1 GB size. Okay, so what will happen, guys, if I say 0? There is no back pressure. Yeah, flow file expiration, I'll come to that. If I say 0 back pressure, what will happen? Is this a good practice? No, it's never a good practice. Okay, please, this is the reason they are putting 10,000 default. Never ever do that. Okay, always, because the queue is meant for buffering purpose. The whole idea behind having this queue, a synchronous system between the two systems, is about having a mechanism so that they can have a smooth transfer of data. So never ever make it 0. Size threshold is about how much data you're expecting in a particular object. Accordingly, for example, 1 GB by 10,000 is the approximate size it is expecting here, but you can always, there is no as such limit here. Okay, now load balance strategy, again, it will come into picture when we're talking about the clustering part. As such, in standalone, it's not required. Now the question is, what is the flow file expiration? So flow file expiration, please understand, guys. Let me just take you there first, and then we'll discuss. So when you're talking about flow file expiration, what does it mean? That what is the way if I breach, let's say, my limit? So 10,000 records or the objects limit has been reached, or I have reached 1 GB limit. Now what happens? As you rightly pointed out, your generate file will stop. It will no longer generate the data. Now what happens? Now your system stops completely, right? You're no longer generating, and the back pressure has breached, right? It means what? What does it mean? Your processor, the next in line, in this case, the Kafka producer, the published Kafka, should be quick enough, or should be probably provided extra resources. Okay, we have to see what exactly the issue is there. Okay, we should take care of what exactly is happening with my published Kafka. Why is it not performing? Why is it not getting in data from the queue? Right. So that is one way, right? You should actually make sure that your published Kafka is working is working really well, and it's actually taking the data from the queue, and queue is getting cleared so that you got extra capacity available, and then the system starts working all over again. Now, what is the flow file expiration? Now, flow file expiration is that if you want this way, let's say that my business use case says that if my back pressure limit is breached, if I've got either 10,000 objects or 1 GB data or any one of them. Now, if my use case says that let my data expire, okay, let my data expire. So what I can say here is that I can, for example, put in here that if my use case is such that if my data is coming in and if data doesn't get processed in, let's say, 2 seconds, 5 seconds, 10 seconds, then I will expire the data. So what are you doing in this way? You are ensuring that you are not reaching your back pressure. What does it mean? It will get cleaned off. It will not get further. It will not go further into the processing pipeline. Are you getting my point? So what 0 second I say, I don't want to expire it. For me, every single record is critical. Even if it leads to the back pressure, let it be the case. But I want all of these records to be available and processed. But if your use case is like your data is not critical, right? Your data is like, if it gets processed in next, let's say 10 seconds, 20 seconds, it's fine. If it not, I let it expire. Okay, so what I'm doing is I'm actually letting it go off. I'm cleaning my queue of that particular record so that it actually helps me not reach the back pressure threshold, right? So in that case, you can actually have this, let's say 10 seconds. Now what will happen is in 10 seconds, your data will, for 10 seconds, your data will be there. If after 10 seconds, the data will go off the file. Flow file expire will drop the records. Can we recover those? No, you can't. Once it goes off, it goes off. It actually it gets marked for the deletion. Okay. So can you think of any scenario, practical scenario, or should I give you? Think about it. So a typical example, you see. So for example, let's say you got duplicated files, right? So error handling case, it actually comes into picture. I think I'll give you a hands-on, then you will understand. But let me give you an idea. A hint is error handling case. So for example, get file, if you want to handle the error while getting in the data, like duplicate file you got or corrupt file you got, what you can do, you can set the time limit there, and you say if it gets processed within 10, 15, 20, 30 seconds, it's fine. If not, I'll just take it off from the queue so that I don't reach my back pressure object threshold. So actually they go sync in hand in hand. So 0 seconds by default, it means typically you would not like the flow file records or objects to be processed. But if you put it 30 seconds, 10 seconds, etc., it will remain in queue for 10 seconds. If it is processed, fine. Not processed, gone. Okay. Now, available prioritizer. I think there was also another question. What kind of prioritizing mechanisms I have in the queue? So the prioritizing mechanism, the 4 that you have: first in, first out, as and when the data comes in, just like you have in case of your queue, FIFO, that will get processed first. Newest flow file first prioritizer. So newest file, the latest file which comes in, oldest flow file first prioritizer, priority attribute prioritizer. So this priority attribute prioritizer is the one which is the one that you can play around with it. You can actually have your own specific attribute, and you can play around with that particular attribute. And so for example, let's say you got 10 attributes in a data in a flow file. Now you want to say that I want to prioritize based on a specific attribute. Okay, let's say if a particular attribute which so a specific attribute is my prioritizer, just like if you are from programming background, if you know there is some sort of custom comparison that we have in programming languages like Java, that how do you want to sort the data based on the name or based on the age or based on, if let's say if it is an employee object. Similarly, the kind of prioritization you can do is based on a specific key or a specific attribute of the data that you have. Okay, but usually guys, you don't my personal observation has been that we don't usually play around with it. The existing ones that we have usually work well for us. I mean, that is the reason they have actually provided it out of the box. But yes, we can do that, and that is through priority attribute prioritizer. So we'll do a hands-on around that as well. Today is more about discussing the concept, but also getting in depth of about some of these concepts that we have. So we'll discuss now how I can make use of FlowFile attributes. As we discussed, the attributes are metadata surrounding the content or the actual data. All right. Now, a flow file has two bits, content and attributes. The attribute portion of the flow file represents information about the data, which we also call as metadata, as we discussed. Attributes are basically key value pairs. So there would be some key, and then there would be respective value for it. Okay, so that's how attributes look like, and we'll discuss them in details. What are those keys? What are those values? Right. Some of them we'll discuss. Now, what is exactly? Why are we discussing this topic? The important thing is using attributes. We can do a lot of data flow tweaking. We can do a lot of decision making. So we can actually, like you see the fourth point, attributes can be used for routing and processing the data appropriately, because we are getting the information about the flow file metadata, right? So we have got information about the data, which is the metadata or attributes that we are talking about. Now, since every flow file has got some or the other attributes associated with it, we can actually have this information available for us to be handy and play around with it. We can have some sort of processing logic around it. We can have some sort of routing logic around it. We'll see how. A typical, very simple use case I can tell you is, let's say you're getting two types of data files, two types of data format files from the customer. One is the CSV file, other is JSON file. Okay, let's take a very simple example. Now, what you want to do is, or the business requirement is, that based on which kind of file it is, whether it is a JSON or it's a CSV or let's say non-JSON, okay, I need to route these files to different processors, because my business logic would probably be different. The JSON data has got some other kind of data, maybe CSV file has got some other kind of business data. So accordingly, I have to handle them differently, have to have different business logic to process these two separate type of file, different types of file. Right? Attributes can come in really handy here, right? How? Because attributes will give you the information about the about the data. What is the data here? The content of the JSON file or the CSV file. But what would be the attribute? The file name, because each one of these files, whether it's a CSV file or a JSON file, will have the name associated with it. And since we are talking about attributes, file name is also one of the attributes. So with my flow file, I will have the name also associated with it. And based on this name, the file name, whether it's star.json or star.csv, I can play around with it. I can do my routing logic. And JSON files can be sent to some logic, some processing logic, and let's say the CSV file can be sent to some other processing logic or some sort of destination, whatever it could be. But what I mean is that downstream data flow can be defined by using some sort of logic on the attributes. Is that clear? Pretty simple example. Like let's discuss about some of those attributes first. Okay, what those attributes are? A file that is picked up from a local file system. Okay, like an example, the flow file would have an attribute called file name that reflected name of the file on the file system, as we are just discussing, right? Additionally, there are other attributes that you have with this flow file, like a path, where exactly the relative path is there on the file. Okay. Similarly, we will have a UUID, which is a unique identifier for this specific, universally unique identifier. It is called as. So we will also have it. These are some examples. There are some other attributes. So, for example, absolute path. So if it is in a file system, let's say, then it will tell you the exact path where this file is. So absolute path is also there. So now, guys, understand key value. What is key? Key is file name. What is value? Whatever the name this file has. Similarly, what is the key? Absolute path. Now, what is the value? Wherever the file is, that path. So, and so on and so forth. So some other core attributes. And now this is out of box. Nifi gives you that. Okay. These are the core attributes which every flow file will have. Nifi will give you these attributes to you. So like priority, okay, the numeric value indicating the flow file priority, MIME type, discard reason, alternate identifier. Okay, there are so many, and also what each one of them stands for. Look at this, for example, MIME type, it says what is the MIME type or MIME type for the file. Discard reason, if any specific region that flow file is being discarded. Now what is happening is that these different attributes are part of the file. Okay, the content plus this attribute. So you don't play around with the content. Please understand, you never ever play around with the content of the file. You play around with the attributes of the file and ETL. Please understand. Okay, you always do your logic or processing or routing, whatever it is, on top of the attributes of a given flow file. Okay, all right. So this is a very simple explanation that I wanted to give you. Now let's quickly do a simple hands-on and let's understand it, guys. All of you have your Nifi up and running, I hope. Okay, could you just do this very simple stuff? Okay, could you just do this? Can you have a processor which is get file processor? Okay, use the route on attribute processor to route the data based on what kind of file it is. Now there should be two different let's say put file processors. One of them takes in the JSON files which are coming in from your routing on attribute processor. The other one takes the CSV file. Can all of you try this out quickly? Very simple it is. Okay, so you can have, let's say, two files you can put in the get file. One of them can be a JSON file, other can be your CSV file. And when you actually start the flow, you should have one file each in put and put file processor, which is meant for JSON processing, and put file processor, which is meant for CSV processing. Can you all quickly do it, please? It's a simple thing, very simple, but I'll start building up from these simple use cases. Let me just do this again. Sorry, once for you. Let me just. How will you do that? So take it very simple. Take the processor and say it's a get file processor. Okay. Now this get file processor has got certain configurations as we discussed yesterday as well. So the property that you have to mention here is that there is some input file location that you have to give. So let's say I give this location as my source. Okay? So this is where my directory is. I'm saying that from this directory you need to pick up the data. Okay. Now file filter, if you see this configuration, it says that all the files, all kind of file, whatever is available in that particular directory will get picked up. So whether it's a CSV or JSON or any kind of data which is available there, it's a regex operation, right? If you see this regex operation dot start, so it says that any irrespective of what kind of file it is, it will get picked up. Now, as we discussed, the ones which are in bold, they are the mandatory properties. So processor will crib if you don't provide them. By default, they have given you options. You are well within your rights to change them if you want. So for example, batch size 10 means at a time it can pick up 10 files. Okay, it can pick up 10 files and get them into the workflow or the data flow. Okay. Similarly, there are other files, keep source file. If after picking up, if you want the source file still to be in your source directory, you can still do that. But by default, it is false. What does it mean? The moment you pick it up from the source directory, it will get vanished. It will no longer be there. Okay. And similarly, there are other ignore hidden files, right? So these are different properties out there for each one of these processes you will have. Okay. Now, so let's keep it for the sake of simplicity, just one. Okay, and this is my input directory. Okay, all right, I'll come to that. So this is my get file. Now, what next should I take? What should be the next one? The next one should be route on attribute. So this is my next flow, next processor. Now I'll connect this. So what does it mean? That my file, so I'm saying success, my file which is coming in from this directory will actually get processed through this processor, which is route and attribute. Let's see some of the attributes here. So go to properties. Now it says what should be your routing strategy. So my file is getting picked up from get file processor, and it is coming to this processor now. Now this processor has to do routing. Now what should be the criteria? How do you want to route it? And that's where attributes come into picture. We would know, as we discussed, that every file which is coming in through the get file processor will have attributes associated with it. Okay, and our business logic, which is a very simple logic, is what my business logic says, that I want to filter out the files based on the type of file. If the file is a JSON file, I want to route it to a different put file. processor. If it is non-JSON or CSV or any other file format, I would put it into a different put file. Okay. So what you can do is you have to actually provide the property here. You have to have your own property because I have to provide the routing strategy. So what I can say is, say my file type. Okay, this is my key, and what is your value? The value would be expression. Okay, here a bit of expression syntax comes into picture, like my expression. I'm saying file name. The file name is actually the file name. We discussed about it, right? If you see here, okay, what I was talking about is this is the attribute file name we're talking about. Can you all see it? This file name attribute. So I will have this attribute directly available. I will have this attribute directly available with my file. So I will have this attribute available in this processor, which is my route on attribute processor. So I'll say file name contains. Okay, this is how you actually define the function that you want to apply on attribute. So colon mark, then contains. So these are inbuilt functions. Then I want to say that what that file should have. So if it is a JSON file, it will have JSON available as an extension. So it will have .json or JSON for that matter. You can say .json as well. It will have this as part of file. So the name of the file will have JSON, ended with JSON or .json. Okay. So this is how I want to do the routing. So this is my attribute. My file name is my attribute. Please take care of the any sort of typo. It will not allow it. It will crib later on. So this is how I want to route it. So I'm simply saying my file name should contain JSON. Then now my routing logic is available. So if you see here, guys, I will have the logic available here, file type, which I have just mentioned, which is my JSON. Okay, JSON file. And then there is unmatched. Okay, so I have got two relationship available now. I think we did not discuss processor relationships yesterday. Guys, processor relationships are how two processors are related to each other. So let's say from one processor to the next downstream processor, I want to have connection. Okay, how would it be? How would they be related? They would be related based on this, that you see here. The relationship. How would you establish relationship between the processors? So here I have got two scenarios in route on attribute processor. One is the file type, which is basically of type JSON. So I have got a match. That could be one scenario because I'm explicitly saying that my file name should contain JSON. Or it could be unmatched. It could be any other file type for that matter. It could be a CSV, it could be a XML, it could be Avro, it could be anything for that matter. But it is not JSON. Okay. So what I'm saying is that, so now please understand that these are the two relationships we're talking about. Now, based on these two relationships, we want to have two put file process. Say put file, say add, and there is another put file, okay, add. Now, what I want to do is these put files, you can, let's say have maybe you can say some target 1 and target 2, something of that sort. So I can say my put file property, the first put file directory is this, where I want to have, let's say, JSON files, okay, and then second put file directory is this, where I want to say, let's say, non-JSON files, okay, because that's what we are trying to do. We want to have two different files in two different directories, okay. So please understand, you're getting in file from a given directory, you are doing a routing on attribute. Here my attribute is file name. Based on whether the file is a type of JSON or non-JSON, it could be anything else other than just JSON, I would route it to either one of these directories. The put file processor directories we have defined. One is the source one directory, sorry, target one directory. The other is target two directory. What I have to do now is I have to establish relationship between these processes. Now, look at this. It is asking how would you want to connect these two processors? Route on attribute processor and the first put file. Okay. So I'm saying that file type. Let's say for the first one, I'm saying my file type should match. So what does it mean? Can somebody tell me? If I say my file type should match for the first put file, what does it mean? What kind of files I'm directing there? So what kind of files do you expect in target one directory?
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in big data analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job. Now let's continue with the session.
Now file type JSON because I'm directing my JSON file into put file. Right. Okay. And then there is another connection that I have to make, that is for non-JSON, non-meshed. Okay. My unmeshed. Because if you see, if you just go here, it will complain. You see, if you see this exclamation mark, it says that still there is one relationship which is unmeshed. You have to take care of it. It will crib, it will complain. I'm saying, so if it is non-JSON, then take it to the next put file or the other put. Okay. Now, few things. Here you see the put file complaints. So this guy doesn't complain. When you get this sign, means it is in stop state. Okay, but it is ready to be executed. So no issues with these two processes, the get file and the route attributes. But if you see this problem, this guy, the put file processor, this is complaining, and it says that you have not taken care of the success and failure relationships here. So if I just go and click over here, double click, what it says is in the setting, if you see, it says that you have to take care of everywhere, guys. Please, this is always it will not anyway allow you, but please take care of these things. Okay, for time being, I'll just do that. What I'm saying is that you have taken care of the first two processors. Now how about these two processors? These processors are complaining that what would happen in a success scenario, what would happen in a failure scenario. What if file is successfully written? What would you want to do? Do you want it to take it to the next processor, or do you want to terminate it within this processor? No, nothing else exists for us. There are no downstream processors. So I'll say if the file is successfully written to this directory, I will say that terminate the case here because I don't have any downstream. How about failure, guys? If it is failure, okay, for time being, so for simplicity's sake, because failure handling, error handling, we are anyway doing later on, I'm saying whether the file gets written or not, though this is not the right practice, guys. Please understand. You should always handle this error scenarios as much as possible effectively. But here, for the sake of simplicity, I am saying irrespective of, because I don't have any downstream processor, irrespective of whether it's a failure or success in writing the file to the directory, I want to terminate it then and there. Okay, for this processor. Now you see, it's not complaining because we have taken care of both the success and the failure relationship because there is no downstream processor. Had there been any failure sort of scenario, so typical world, what will you do is if success, then put it back. So success will get terminated here. If it is a failure, what would you probably do is that you would have some sort of logging done, explicit logging done. Maybe let's say you can, I will see that scenario, some sort of explicit logging done using some log attribute or something, right? Some other processor. So what I mean is that if there is some failure happening in terms of writing the file to this processor or this directory, I will do some sort of logging, some sort of monitoring so that I would know how my data flow is working. Okay. But for the sake of simplicity, as of now, I have done it. What I have done is I have terminated both of them at the same because I don't have any downs, and I will do the same here as well. Okay. Now you see my data flow. I'll explain quickly. Get file. They are all in stop state because you see the red mark here. My data flow looks like very simple. Get flow processor takes file in from a given directory which we have mentioned. Now route on attribute, it only routes on one attribute, which is the file name, checks whether the file is of type JSON or CSV, and based on or non-JSON for that matter, and based on what is the type of file, okay, it will either put it into target 1 if it is a JSON file. If not, then it will put it into target 2 because it's a non-JSON. Okay, guys, now pretty simple. Now you just start them off. So I've started them. Now what you do is you just go and put the data in one of those files. So my target 1 doesn't have anything as of now. Target 2, let me remove if there's anything there, and I'll just put some data in the source folder. Okay, in a JSON file I should put in. I have some JSON. Yeah, let me put these files only. So I'll just go put data in the source. Now you see, because we mentioned that they should get vanished the moment it gets picked up. Okay, so it should. What's the issue here? Just a second. I see. I've got these different stuff as well. All right, 1 second. Let me just take them off. They also. Let me clean that up, guys. By the time, please build it. Please build it. Let me just clean that up. All of you, please do it. And let me just clean it up quickly. And see if you can have the files in two different directories that you have. I need to just clean the existing. Just put the files there in the directory, start the flow, and you should get the 2 files there. Done. There was some few flow already created, and the problem is the get file was pointed to other flows as well. You got it, right? So that's the reason they also started. Clean them off. Done. All right. So if you are done, let me just, guys, now since you are done, can you also do one thing? And now here you have to take care of one thing. You have to refer the expression language in NiFi a bit. Okay, what other attribute you can pick up and do routing? So for example, not file name. Other than file name, the relevant attribute, I leave it to you. I leave it to you completely. So play around with it. Okay, any attribute you can pick up, then we can discuss which attribute you have picked up and did the routing on. Any other attribute than file name, some of the attributes that we discussed, and do the routing. So you have to stop your processors, you have to edit them, make some changes in the configuration, route an attribute, and do the stuff again. Okay, so you can take up any other attribute than file name. Or if you are taking file name in also, then what you have to do is include any other attribute as well. Do an or and. So error, if there is any, just go to bulletin board. So here you will see the error in the bulletin board if there is any. So like you see, I got this error because I had been running some other processors as well. So you will see in the bulletin board here the error if there is any. I'll anyways walk you through those error scenarios as well. Did you get it? Where exactly the error would come in? All right, perfect. So I hope all of you are fine with it, right, guys? It's pretty simple one. Okay. Now, any other attribute you can take up, anything that you want to have around it. And if you have any doubt, right from today, guys, let me tell you, just go here. Okay, this is the best thing, best practice that you should have. So NiFi expression language. Okay, and this is the guide. So keep this always open with you. This should be always open for you. Always, please keep it. Now you can take up, though I will discuss in details each and everything. But I have just given you a hint that file name, and then I applied a function there contains. So if you see here, you will see all those functions available that we discussed. So for example, the contains function. So if you just search here, it will have this contains function. Okay, there is an is empty function, there is an equals function. Look at this. Okay, equals ignore case. And how do you use it? Look at this. File name equals ignore case, and then the file name explicitly you can even use this. Okay, you can make a specific file name that if only file name is this, then I will put it into this, otherwise I'll not. Okay, so they are different. It is very powerful, the expression language, and trust me, the NiFi's actual power comes in from its expression language, and every single release they are actually making it more and more versatile. So take it up very quickly. Any one of these, I'll send you the link. I'm sure you have it handy with you already, but still, so you can make use of this expression language syntax and do any other attribute and any other function. Let's put it this way. It's just for hands-on, simple hands-on. All of you, anything, I leave it to you, which attribute and which function, but just for practice purpose. You can see on my screen, I have just put in those files, and these files got splitted. One of them gets into one of the processor, the other one gets into other processor. All right, and make use of expression language, even if you are probably comfortable with some of the functions already. Always keep it open and in a separate tab. This is your Bible. Okay, always make use of it. They have given you the syntax, and they have given you the definition also, that how to make use of it. Yeah, very good. File name attribute and ends with, that's also fine. So we would have used even ends with here, right? If I assume .json will always be there, right? Then I can make use of it. Okay, anyways, expression language we'll definitely discuss in details, but just to give you a brief about it. All right, now the next bit, guys. So the next bit is empty. Yeah, so you can have even in a specific path you can do. Even in a specific path, like we have taken the absolute path. Anyways, guys, I don't want to make it very complex now, but I'm just giving you the idea that what you can even see whether if there is any file or not, if your directory is empty or not, right? Can you do that? Can you think about it, guys? Take it as an exercise, or you can do it right away if you want to do. If my directory is empty, let's say, then you want to figure out, or you want to raise an alert or failure, let's say. If it is not empty, then you are anyway picking up anything which is available in directory, process it, put it in some put file processor. But if it is an empty directory, so assuming, what are you assuming? That your directory, and what you have to do is you have to always keep for a flag as true, that your once you pick up the file, your file should still be there. I'm talking about a real world use case, guys. The real world use case is that you are picking up files and you're expecting there would always be files in a given direction. Okay, but what are you also mentioning? That I don't want to vanish the file, I still want my file to be there even after I have processed it. Okay, but if there is some use case, because of some reason somebody has deleted every single thing in that directory, you should be able to pick it up using NiFi data flow and raise a failure case. Maybe you raise it to you put it something, you raise it, I mean, you actually do a log attribute, which I will discuss, but you got the idea. The idea is, in a directory, I want to see that there should always be something available. Okay, so that is something, a use case that you can try out. I have given you the real world business use case also, because there would be requirements, right, wherein you always expect some data in a specific folder. So if it is not there because of, let's say, the upstream system is not putting in the data here because it failed. You got my point? It failed, so you did not have any data in that particular directory. But that's not an acceptable business scenario. So in that case, I should be raising a flag. I should be able to know about it, that I'm no longer getting data in that directory. Maybe something is wrong in the upstream system which is pushing in data here. Are you getting my point, guys? All of you? Am I clear? So I need to come to know about it, that I don't have any data available in that particular directory. So I should be able to figure that out using NiFi data flow. So that is something that you can try out, or can take it as a work from for your takeaway exercise. This is a typical business use case. So what you can do is, though I'll just explain the error handling quickly. We are getting in there, but what you can do is, you can just get in there, as I told you. In fact, logging also, like this particular topic next, so we'll discuss about it. This is one way. So you can just go, okay, and check it out, your logs here. I just had restarted, so it is not there. Now you can also have, if you can just go here, okay, and Apache Nifi installation directory, okay, go to your logs, and then the application logs. Okay, this is where you can tell it. Okay, you can tell it, and then can see what exactly the issue is. Okay? It must be related to your cluster setting for sure, but it will give you any error if you have. Okay, it will be available here. So you can just figure out what exactly the issue is, because you got always, how do you go about it? So you have to see where exactly the problem is, right? So the get file got processed perfectly, then through connections also it's working fine. The first one, route on attribute, is also working fine. So it has routed now. Now the problem is with the put file, because it's not getting in there in the directory where we are expected it to be. So what it means is that there is an issue related to this file, this particular processor. Now all the logs, right, unless you specify, and that's also we will discuss how you can actually make it specific to a particular processor, the logging. But for now, since you have not done yet, what you can do is, you can just get into your bulletin board, or you can just get in your app log and do a tell and see where exactly the issue is. Okay, just figure that out. That would give you the clue where the issue is, and then we can take it from there. Okay, and guys, if you can all probably do me this favor, if you can start off with the same configuration, like standalone I'm talking about. So it's 5 minutes job to start NiFi, right? Cluster anyway we are getting in. So the moment we get in the cluster, then again we would all be in the same set of setup, right? So that would actually help us all to be on the same page, same stage at a given point in time, and then when we move into the clustering, we all will get into the get into cluster. So if I'm not asking for more, I think it would really help if we can all have the same setup, so that even though you have got already pre-configured setting up, done everything, but I think that would be better if we can all have the same setup. So for now, it is standalone. Okay, you can have your cluster up and running, let it be, just for the, so that we are all on the same page and the same setup we are trying out. All right, the next thing is log configuration and monitoring logs. Now, let's say something goes wrong somewhere, right? How would you know? Or let's say even if it not goes, even if it doesn't go wrong, but you want to monitor how it's happening. What are the logs which are happening? Which particular processor is doing what? What are those different attributes, right? Which are getting in through the flow file. Your flow file is going through your data flow. N number of different processors, complex flows. Now, each one of these processors will add some or the other thing, will change the characteristics. So, for example, let's say you start off from basic CSV, let's say. Now you basically do some sort of ETL on this CSV. ETL in the sense some sort of processing based on the attribute, let's say, like we were doing in the route on attribute kind of thing, right? Now, what I want to figure out is how did my flow file changed? What all those? So let's say in route on attribute, what I did, I added up extra attribute there. What was that attribute? File type, right? I did add an extra attribute, and that attribute was file type. So and this was like contains, means either it will be a JSON or not. What would be the value, guys? Let me ask you here. I said file type is my attribute, and my value was file name contains JSON. So if I see in the logs, what would exactly it be? If you see the attribute, what would be the value of that attribute? What do you think? Am I clear in my question? I'm saying if you see the logs, what would be the attribute there? Boolean type. Very good. Absolutely. It would be a Boolean type. Either it will be true or it will be a false. Very good. Right? I'll show you that anyways. But so that is where actually your logs would help you. So for example, you can just visit your logs and see whether it was perfectly logged or not, whether you got the file type or whatever that name that you have given for the attribute there, was that perfectly appended or not by the processor, which is your route on attribute processor. So it is expected to put in extra attribute in your flow file, which is file type for me. It either should be yes or no, or true or false, like Balaji mentions, based on what kind of file it is, right? And then this is how you would go about debugging it. This is how you would go about fixing out or figuring out the problem. Am I making sense, guys, here? Are you with me on this, what we are talking about? Right? And let's discuss in details how we can actually make use of this particular functionality in NiFi. How we can use the logs for monitoring and configuration. How we do configuration, how we do monitoring using logs. Okay. All right, guys. Now let's talk about the logging part. So there is one configuration file in NiFi that manages all the logging operations, and I'm sure all of you know that. That's a logback.xml file. Okay, it's a typo, logback.xml file. Okay, and this directory is under your config directory. Okay, so if you go to your NiFi home in config folder, you will see that particular XML, and all your logging related configuration is in that XML. And you play around with this XML a lot, guys. Okay, especially for the for the logging, for the debugging purpose, for the monitoring purpose. I'll explain how you play around with this in real world logback XML a lot. Okay, you make changes there and you see what exactly is happening. So let's say a particular process is giving you issues. Now you want to log that particular processor's processing, what exactly it is doing, what exactly wrong with it, what kind of logging it is doing. You can explicitly log for that particular processor. That's possible. Okay, so that we will see how we can make use of a specific processor. Okay, and they can do the logging for that particular process. Now, before we get in there, let's discuss brief about what exactly logging configuration is all about. So as we discussed, there is a file under this particular location, which is your NiFi home configuration. We have got a file logback.xml. I'll go there shortly. It is good to know that this file can be modified on the fly. Please understand, you can make changes on the fly. You don't have to restart your NiFi. Okay, just you have to make some changes, some sort of changes related to debugging, monitoring. Let's say you want to find out for a specific processor. I'll show you that, and you can make changes on the fly, and then it will get reflected. You will get that extra file created in your logs for that specific processor, and you can see what exactly is happening out. Okay, so logging helps in debugging and monitoring NiFi. goes without saying. So if we can want to see what exactly happened, what went wrong, why did not the put file process did its job well, we can just go in there in the logs and see what exactly happened. Okay, so that's and monitoring we'll see. Now, before I explain this, let me just go there and open this file for you. So this is the configuration file we discussed about. Okay, in this configuration file, I'll talk about the other stuff also. They are all related to configuration, as the name itself says. Let's focus on logback.xml. Okay, so this is your logback.xml file. Now, in this particular file, you see there is pre-configuration. There is some sort of configuration already done for you. And at the same time, while you are there, at the same time, you should go and open your log files as well. Okay, so you just go and check out your log file directory as well. Here are the logs. That's the configuration. And where would actually logs be generated? This is where the logs are getting generated. Okay, so if you see nifi.app, nifi-app.log is one, nifi-bootstrap.log is another, and these are the ones which I've created. So I'll explain them. So don't worry about that. If you see in your nifi installation, you won't see status check. Okay, these are the ones I have created. So we'll see that. And then nifi user log, that's another. So you've got three types of log files in your nifi installation by default. Okay, and they are all configured here. Look at this. All the configurations related to your log files are done here. This is for your app file, app log, the nifi-app.log. That's your app related configuration, right? This is your user related configuration. This is your bootstrap file. This is your booting related configuration. Like I'll explain what exactly they are. And this is extra that I have added up. I'll explain it how it is working. Okay. So if you open up your logback XML file, guys, all of you, can you please do that quickly? You will see the file that I've shown you, but of course, some of the part will be missing because that's extra that I've done. Okay. Now look at one of these tags. Okay, let's see for app file what exactly it signifies and how do we make sense of it, so that you do understand very well how the logfile.xml looks like and what exactly does it have. Okay, so like you see here, it will have the appender name. It is for app file. Okay, and it has got its own referencing classes. Okay, what you should probably understand is, if you see the max file size, what you will have is, I'll come to that, Vijita. So what you have is the rolling policy class. So you have a rolling policy, okay? And look at this, guys, the name. So let me just show you this. So if you see, the name is clearly mentioned out there, that this is the file, nifi app.log file. So we are talking about this file. Okay, so this particular logging is for this particular logging is generating this file. Please understand that. Okay, now what is the maximum file size? 100 MB. So it will have 100 MB as the maximum size. After that, what will happen is, it will get rolled. It will get rolled down. Look at this rolling policy. So what it will do is, it will be 100 MB. It will get increased up to that size, because this is how we actually do. It's just like log4j. Okay, it's basically built on top of it. So their logging framework is based on your log4j framework. So you have got 100 MB size specified. Then the rolling policy is that after 100 MB, this is how the file name patterns looks like, the rolling pattern. Okay, look at this, nifi app underscore and then time. It will get associated with, like in your usual log4j it happens. Maximum history is 30. So at a time, 30 files would be there. Based on your use case, if you want to have more than 30 files, let's say for a year, and so you can increase this number. Okay, you can always do that. So by default it's 30. So it will have 30 files, each file 100 MB size. And once it goes beyond 30, it will start cleaning up the stuff. It will have last 30. Okay, and so this is how actually you take care of the logging part. So if you have to put in your extra log, this is the format you have to do it. I'll show you how to do it, but please understand that this is how my logging in the logback XML works. And then, so this you define the appender name, and you see the down, the tag. So it says what kind of logging we are doing. It is info type of logging. Okay, it is the info type of logging we are doing. And appender reference, it is saying app underscore file, and the app underscore file is at the top, the appender name. So what you are saying actually here, please understand. Let me go to my logback file now. So look at this. I've got my app file, okay, all the information related to it. And then at the down, if you go here, I'm referring it. I'm saying that I want to log the info, okay, and the reference is app file. So logging related to that particular appender, it will get appended in the app file, the nifi-app.log file. I'll have all the information related to my application, right? This is how logging is done. Now, if you have to change it, you can always change it. Keep all these three different logging in place. Don't play around with it. Okay, and you can have yeah, if you want to play around with it, you can play around with it in the sense like, let's say I want to have more than 30 historical files size. I want to actually, let's say, have not I will not wait till 100 MB, because every day, on an average, let's say this much data gets generated, so I will just reduce the size to be this much, so that the rolling happens, and so on. All these things, this is liable to be changed. You can play around with it. What I'm saying is these three files, should be there, because they are meant for specific purposes. Other than that, if you want to bring in extra logging, you can do that, and we'll see how we can do that. Okay, now log file is rolling every hour. Okay, so the configuration is every hour or whenever it is going, or 100 MB. So it is this is how it is. So every hour or 100 MB, whichever is earlier. Okay, besides, we keep only 30 files worth of history. Based on your retention policies, you can always update. Okay, you can probably, let's say they are compliance requirements, you want to have entire stuff out there, so you can always keep it as much as you want. Now, please understand what each one of these files, the three default files which NiFi gives you, what these files have and what exactly they are meant for. So the app log file, this is the main log file of NiFi, and logs all the activities of Apache NiFi application, ranging from NAR files, which is your core files loading, which is a boost, which is like the core APIs of NiFi, to the runtime errors or the bulletins encountered by NiFi components. So yesterday there was a question. I don't know. I don't remember. There was a question related to logback XML and bulletin. How they are related. So now is it clear, guys? How is it related? So whatever that you do there, right? Whatever is being displayed over there in the bulletin, okay, that's at the GUI side, right? You can directly click and check it out very quickly, that what exactly happened to the flow, the logging. But if you want to have a detailed analysis, if you see the source is app.log, everything is here. Every error that you will get in here. You will see, oh, what exactly is the issue with the flow, why it is not working, right? All those things you will see here in the application related. That's the reason it is app.log. Okay. So this is where, so whenever you get an issue, you know now where exactly you should go and refer to. This is the place you should go and refer. Okay, the app.log. Then NiFi bootstrap, the second file. What is it? It logs the bootstrap logs. Apache NiFi standard output. All sysouts in their core code. Okay, because in their so I'm talking about the application, the flows that you create, go to app.log. If you want to find out the exact logging that the Apache NiFi framework is doing, it is bootstrap.log. Okay, so if there is an issue related to Apache NiFi framework itself, right, all their logs will be available in the bootstrap log. And finally, the user logs, okay, it logs the events related to all your API calls, your logging, your security, all those things that gets into your user logs. Okay, so web security, web API config, your HTTP calls, you will see API calls, so user authorization. So all those get logged in user.log file. Very important concept. Please be clear about these things. Usually the first and the third, because you don't usually play around with bootstrap.log. It's completely driven by Apache NiFi framework. Okay, but the one that you play around with the most is app.log, of course, and then user log if you want to figure out if there are any issues related to your API calls, your security related stuff, okay, and authentication related stuff, because it first goes through that flow, okay, internally, and then it starts.
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in Big Data Analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job. Now let's continue with the session.
Logging at the application level. So this is how it happens: the bootstrap log, then the user log, and then the app log. Okay, this is how it happens, and they have given these three different separate files for each one of these use cases. Make sense now, guys? Okay. Now please go and have a look at these three files that you have in your directory. Equipped with this information, we know what each one of them has. Also look at your logback.xml. Okay, and see these three files. Please quickly have a look at it. And guys, can you also check it out? In your app.log, whatever exercise we have just done, is it getting logged? Do you see that particular flag? What particular attribute, file type, I think? Can you check it out whether the file type is available there or not? For that, you have to log the attribute. Okay, so I'll come to that, Vijita. Just hold on. For that, you have to use a processor called log attribute. So we'll get in there. Just hold on. Okay, now here comes the exercise. Okay, improvise on the previous data flow. So I think you can even change the existing flow. Okay, you need not create from scratch. Add additional attribute key and value pair to flow file if the file type is not JSON type. Okay, so what does that mean? That what you have to actually do is that if it is success, then it gets into that put file wherever it is. Okay, and now you don't have to use put file. Use log attribute processor as the destination and write logs to a different file for monitoring purpose. You're getting my you're getting my point. What I'm saying is that in this case, what you have to do is we are trying to make use of a different processor, which is log attribute processor. Okay, so I think let me just give you a little idea what exactly we are trying to do. Just do that. Okay, so you can see this. So I'll just take it off. I'll stop it. I'll just okay. So let me just start from the scratch only. That's fine, so that you are not confused. What I'm doing now is, please understand, I'll just take it the get file. Okay, and what I'm simply doing here is that same exactly source you can put in here. Just go here, put my source as is. Okay, now I'm putting up the same stuff again, which is my route on attribute. Okay, and why I'm using this specific processor again, guys? This is because this is what this particular processor is meant for. So answer to that question is that that will come through practice. Like I'm saying, let's say file type again, saying that my file type, my file name, or you can put anything. I'm just the scenario that we had earlier, a simple one, JSON. Please make sure that you get it right. Otherwise, it'll crib. If you do this, it'll crib. So we will also see that. Okay. File name contains JSON, and this is my expression. Okay? Now I'll say apply. Now file type is the additional attribute. Okay. Now what I want to do is I want to use let's say I want to log the attribute, because as you guys are asking, right? As we are seeing that I want to see whether what exactly this particular attribute is, which is coming in. So I'm saying log attribute is my destination. Okay, so it will give me the information, logging related information. Okay, now what I'm doing is, please understand, log attribute is about logging all the attributes that you are getting. Please understand why are we doing it. We want to see once the file that my flow file goes through the entire processing pipeline, entire data flow pipeline, I want to log all the attributes related to that file. All the attributes in the sense, including this file type, whatever that file type attributes we will have, that will also get logged, because it is at the end of my data pipeline. So all the core attributes, file name, UUID, MIME type, file size, etc., and also path, absolute path, also whatever that you do on the fly, like I'm adding a file type. Okay, that will also get logged in this. So this particular processor is for that. Okay, so what I'm saying is here, if it is a successful scenario, okay, file type, if it is a successful, okay, I am logging it to my log attribute. Okay, You connect this also. So from this file, I am putting data into route on attribute. Route on attribute is checking whether the file is a JSON file or not. If the file is on JSON type, success scenario, it directly goes and logs in the log attribute. Okay, but if it is not, now we are not putting in the success and the failure there. Okay, but if it is not, so let's say I'm saying that I want to use another attribute, another processor says that update attribute. So you can use another attribute, another processor update attribute. So in this case, and which case it should be, guys? It should be in the case of which one now? The file type or unmatched type? Where should I be putting in there? Are you with me? What I'm saying is I'm taking in file from get file, updating its attribute file type. Okay. Now this file type will either match or not match. If it gets matched, it is getting into the log attribute processor directly. But if it is not matching, then I'm saying you go to this particular processor. I'll explain it again if it is not clear. Now in update attribute, what I'm doing is I'm adding up, let's say another attribute which says file type not JSON. Okay, this is my property name. The value I'm saying yes, because this is the attribute that I'm expecting here. Because if this guy, if my file is getting routed here, it means that it is not of JSON type. So my attribute and the value corresponding should get updated is that file not JSON type is the key and the value is yes. Okay, so my success is this, my failure is this, which is unmatched in this case. The first two processors are not complaining, the last two are. Okay, so this guy is complaining, and what's the complaint? The complaint is that what would happen to the successful scenarios. Okay, so what I'm doing is I have updated it. Now I will go and log it. Okay, and here I'm saying I want to find out, I want to check it out what exactly is happening on this particular processor. Is this flow clear, guys? Please understand what we are doing. We are making use of logs. First of all, please understand we are making use of logs to see that what is happening throughout my flow. Okay, so in this case, I'm making use of logs, of course, to see what is happening, right? So I'm using a log attribute processor. Now, this log attribute processor will get every single attribute which is in place, which has happened. Because you see here, these are my terminating processors. So, assume a scenario, my file is of a JSON type, gets through route on attribute, it checks for whether it's a JSON or not. If it is JSON, gets into log attribute, but it will have an attribute called JSON file type, right? When it gets logged, it will have an additional attribute which is of file type. Got it? Then, if it is not, now if you can help me, if it is not of JSON type, what does happen? Any one of you can volunteer. My file is JSON. I understand the flow perfectly. It's okay. But if it is not, then what happens? 30 days history, does it mean how many files would be there? So it depends on your size, Jerome. So every day, as we saw, there would be a file created, right? Or 100 MB. So if let's say in a given day, if there are more than 100 MB files generated, then you will have multiple such files. Getting my point? Otherwise, you will have 30 files for 30 days, assuming 100 MB size is not breached. Okay, unmatched, absolutely. So it will get to unmatched, and unmatched will go to update attribute. So what we are doing is, if my file is of not JSON type, I am getting into another processor through unmatched connection, and update attribute processor is doing what? As we saw, right? Update attribute processor is adding up another property out there, another attribute out there, file type not JSON, which is value yes. The value yes. So now my question is, please understand, if my file is of JSON type, how many additional attribute you will have other than your core attribute? Your core attributes are coming in with your flow file, that's fine. But if your file is of not JSON type, if is of JSON type, how many attributes, extra attributes you are getting created through this flow? One, and what is that? That is file type, right? Which is file type. Yes, very good. But if it is not JSON, if it is some other format, how many attributes? Just one, right? Or two? Two. And what are they? One is file type, which is true or false based on whether it's, of course, it's not JSON, so it should be no. And then update attribute, which will put in that extra attribute, file is not type, whatever that we mentioned here, that file is of not type thing, file type not JSON. Okay, that will come in only in the case the file is of not JSON type, because that's the explicit case we are handling here. But all of the in each scenario, whether it's a JSON type or non-JSON type, it will get logged in the log attribute processor. So my log attribute processor is where I'll get to see the attributes of my flow file, irrespective of whether it's of type JSON or not. Am I making sense? And here, if you want to see on the fly, what is happening, what kind of information you are getting, you say info. Bulletin level, you put it as info so that you can directly see on the GUI. So info means it will show you all kind of logs there, right there in the bulletin. Okay, so it'll if you just go to bulletin after this, you will see all these attributes out there for that file. So just we'll change it to bulletin level. Bulletin level info. Is that clear, all of you? And please also understand what we are doing. Parallelly implementing, very good. And please understand what we are doing and what exactly is the purpose. The purpose is using the logging and also changing the attributes, adding up the attributes as my flow file goes through the process flow or the data flow. So I don't see any error now. There are no explanation marks because we have taken care of everything here. Are you done, guys? Please let me know once you are done. So if done, why, you know what to do now. Just go and push some data there in the directory, the get file directory. Just go and push some data out there. So please push in few files in the get file processor directory wherever you have mentioned it, and please push two files. One is of type JSON, other is non-JSON, CSV, like we did earlier. And like you see, I've just done it. For me, look at this. I have put two files. One is of JSON type, other is of non-JSON CSV type. Look at this. It has given me one file in the update attribute expected, right? It was expected because one of those files, as we discussed, the CSV would go to update attribute and the JSON would not go to update attribute, but both of them will go to log attribute. Look at this, two files, two objects there. Okay, and then we will see the logging, but I see a lot of issues the reporting. Any problem, guys? First of all, what you are seeing is clear. Like whatever you see on the screen, is that clear? Like how's it happening? I pushed in data. Let me do it again. Okay, so what my flow is on. I'll go to my source directory. Okay, these are the two files I have. I'll put it into my source directory. Test gets consumed, and I'll refresh, and you see 4, and you see 2 here. Okay, here I have 2 because these are CSV files. Okay, and here I have total 4. First 2 I had put it earlier, and 2 I've got more. So total 4 files I've got in final, this log attribute. Okay, now, okay, I'll take up your issues, whatever it is. How many of you could do it? I mean, could get to that level, like wherein you have the file segregation and then finally getting into the log attribute without issues? How many of you could do it? I could. Okay, else, and because I'll make it very, very complex as we go forward. I started off with 1 or 2 processors, and we'll end up around 20 plus, even more than that. So now you see just 4. We'll end up around 20 plus, even more than that. So we'll even create process groups. So I want you to be very clear with the basics in the start. So that's the reason every single thing you should be able to do it and follow. Okay, yeah, I got it. So Jerome, you got it, right? So you are getting those additional attributes there. Can you see that in the bulletin board, guys? If you just go to your bulletin board, or you can just check it here even. Okay, if you just go here and check it out. Okay, it's getting logged, all the attributes. Let me just show you here even. Bulletin board, just go here and look at this, guys. In the bulletin boards, say no auto refresh. Look at this. One of the files will have 2 and the other file will not have. Okay, so like look at this file type not JSON. I have highlighted it. Yes, file type is of not JSON type. Okay, this is the additional attribute that it has added up. Value is unmatched. Look at this, because this is in the unmatched part. Okay, guys, is that clear? So you are getting these things logged here. Those who could do it, do you understand it completely? How we can do the logging and how you get the attributes logged. Now, let me take issues. Who's facing issues. So guys, quickly, those who couldn't do it, I want this exercise. I mean, you should all be able to do it because we'll be building up further. So each one of you should be able to do it. That's the power of Nifi. You can quickly, make the changes. It's not like coding and deploying here, right? It's pretty simple. GUI, data flows, check it out, add additional attributes, play around with it, see if you are getting it as expected in the log attribute. Now the problems, the flow is working, no errors. Okay, even guys, you can go to your log file, just refresh it and open up your logs, app.logs. Okay, because bulletin board getting it from here, as we discussed, that is the source, right? So, oh, I'm sorry, I actually I have put it in a different this thing, sorry. So I have done the configuration, so I'll get it here. Okay, I'll get it here. I'll explain how to do it in the login, but for now, bulletin board is the source for you. Okay, I'll show you how you get it in the logs. Okay, for that some configuration needs to be done, which I'll explain it to you. Like you see here, I've just done it, and like we are doing 8:30 in the morning my time, 21st July date, and look at this file type not JSON. Right? That's the additional attribute that we have added up, and this is that attribute on the routing, I guess, unmatched. That is for the non-JSON file. For the JSON file, you will have it file type because it's a success. So you will not get that additional attribute here, which we have here. The file type node JSON will not be here because this is for the JSON file. This is for the non-JSON file. Okay. So before I come to see your problems, let's do one exercise, guys. Same problem. Now, one thing that you have figured out is that I can see on my bulletin board here what exactly is happening. Okay. So I have actually, so please, those who are not seeing anything, please see that auto refresh is enabled. Okay, if it is not enabled, you will not see anything, your logs will go off. Okay, so the auto refresh should be enabled. If even if then there is an error, we'll see what exactly the issue is. But do this thing, this step first before we see what exactly is error is. Now, what I want to do is, guys, usually this happens if there is a processor like this, like log attribute is a very critical processor. Now, in this business problem, let's say if this is a business problem, the business problem context here is that I want to see what is happening with my flow file, how many attributes are getting added up, what are the values. So what I have to do is I want to see the logs. Okay, those critical processes, I want to see the logs in my log file. Okay, in my log file, I want to see the logs. I want them to be logged. Okay, for that you have to make extra configuration. What you can do is you can have explicit configuration done for any specific processor. In this case, my log processor, I want to have an extra file created. 3 files we already got, right? The extra file I want to have explicit logging done, being done for this particular processor, log processor. I can do that. Okay, and how to do that? You have to, of course, change your which file, guys. If I have to make any changes in logging framework, which file I need to change? XML, logback.xml. Absolutely. So please go to your logback XML configuration, logback XML, open it. This is your logging XML. You won't have this, but I have already done it. So this is, I am saying, okay, this extra information you have to add. I want to actually log, let's say, status. Okay, so I want to it can be any name. I mean, it's not specific, this status underscore log underscore file. It can be anything for that matter. But what I'm doing is, please understand, I want to log the information related to this processor. Okay, so I'm putting up this particular logging is almost copy paste. Look at this. There is nothing which I've changed from their app file. Only the thing that I've changed is this name. Some other file I have to put in because I want to find the logs in that file. I want to create an explicit file. Okay, and that's it. Nothing else. And of course, you have to put this also. Like you have to change this file name. So these are the places that you have to change. I'll put it in here for you that you can all do that. Please add it into your. I have sent it to you. Please add it into your logback.xml. Separate. Tag here. Look at this. So this is the file you are expected to see in your log directory after this. So logs, under logs directory, I want to see this particular file created. And once you have done that, you have to refer it like we were doing in F file. I'm referring it here using this. I want to append the logs there. Okay. So what I'm saying, what I'm telling my framework is that my processor name is this log attribute processor. You can do it for any processor you want. Level is information info, and I'm referring to this particular tag, which is status log file I've defined already. So these two things you have to add in your logback.xml file. and just save it. You don't have to restart. And then again push files. See if that particular file is created or not now in your log directory. If created, just open it and see whether you can see those attributes getting logged or not. Like I'm saying you here. You see, I have already created this file and I can see these logging happening here. I can see only specific to this particular processor, I can see the logs. Whatever is happening in that processor, everything will be displayed here in a separate file. Done, Sanjay? So you can see that file created, and also if you put in data now, you should see this, and you don't have to restart that file. You would see these different logging happening here. That's a very important tool in debugging, guys. Any specific processor, if you want to debug, you can actually do this kind of logging. And how it happens in real world, let me tell you, you actually monitor this particular file because you are expecting certain attributes, you are expecting certain information logged in this particular file. Now you can even read this file and do the monitoring. Okay, I'll explain you in the next scenario, because this is your most critical processor. So you can see what's happening here. Everything is getting logged. You can tell this particular file, and you can have a flow created out of it. I have sent you both the configuration that you need to add. One is the definition, and the other is the reference. How would you refer to that definition? And also then put the file in the flow, two files, and see if you're getting these things logged in here or not. Can you tell how to add? So I've sent you both these tags, right? Information. So go to your logback.xml. This is in your config file, config directory in your installation. What you have to do is like that. The first one you have to append. Okay, you have to add here. So let me just tell you where you see here. So I have appended here. What I'm saying is that you have to create. I'm telling my Nifi that you have to add one more log file. Okay, this is the one, and I'm referring it to, I'm giving it some name. The definition, it actually is the definition for the logback.xml, that what you want to do and which file you want to create. Like I'm saying, I want to create this file. Okay, and then you change the, it is exactly the app file. If you can copy paste from existing logging and just make relevant changes, you should be good to go. So look at this, this reference you have to change. You have to put some name. Everything else remains the same, history, etc. If you want to, you can change. And then you have to refer it at the bottom. You have to refer it at the bottom that the top logging I have defined, I want to use it for this particular processor, log attribute processor. This is your API, core API of Apache Nifi. Okay, label is info. If you want to only log errors, you can do that as well. If you don't want to log everything, only errors, then you can say error. Then only errors specific to that processor processing will get logged here. That's absolutely okay. Right? I'll not leave anyone behind. I'll take everyone along. So if there are issues, there are problems, we will sort them out. Don't worry. These are very basics we are discussing. Since I will actually take it up where the complex scenarios later, so I'm putting up a lot of efforts here so that each one of you do understand what we are doing. Very, very important. And then monitoring. How monitoring? Because once you have got this logged for a given processor, you can do for n number of different processors for that matter. If you want, you can actually monitor that particular directory, that particular file. Okay, you can tell it, because at the end of the day, this is another directory, another file there, right? You can even tell this file, this processor name tell log. Okay, I'll just show you that. I'm giving you extra information. So if you see here, there is a processor, and this happens actually very frequently in the industry. I think we'll do it. I want you to do it today. Tail file. Maybe you can try out. Tail file, you can use this processor. You can tell this specific file, the logging file that you have done for that processor, and check out if there are a lot of errors happening, if there is what kind of errors happening, what kind, you got it right, because you got the complete content out there. Now you can monitor that particular, because for you that's a critical piece of your flow, your data flow. You can check out the logs, you can play around with the logs, see what exactly is getting logged. Are there too many errors? What kind of errors, right? You can even do the notification and send an email if the error goes beyond a particular threshold. Okay, so that those are is that clear what I'm saying? So this is the exercise that we were doing. Okay, now this is the exercise which I want you to do, the improvisation. Okay, it is on top of this. We have done the logging, we figured out. Now what I want you to do is use a tail file processor of Nifi to let Nifi tell its own log file from previous exercise, okay, and perform the required operation when some conditions are met. Example, send an HTTP request when logs of warn and error levels are detected. Okay, so what exactly it is that you have to use tell file processor, which I was just telling you, tell this particular file, the status check file, log file, and check it out. Let's say if my warning level or the error level, usually in the industry you will check for error and warning only. Warning actually nobody bothers, even not much, but error level you usually do it. But in your case, you may or may not get error, because if your everything is working fine, you won't get error. Then in that case your flow will not get triggered, right? So you can even put for the info, okay, for that matter, assuming everything is really working well. So you can put on the info level, check the content. I'm just telling you some of the processors name. So what you have to do is, please write it down. Tell file processor, split text is another processor, check content, check on content, route on content. Sorry, that is not check on content, route on content. That's another processor. You have to make use of these processors. Okay, some sort of R&D you will have to do. You have to figure out. What I want you to do is, once you have figured out which all processors you want to do, but the business problem is clear. Okay, this is real world problem. Log that particular file you tell, and then keep doing it. Keep doing it continuously. Keep getting that data. Figure out how many number of info messages have come in. So if info messages go beyond, let's say, a certain threshold, okay, maybe let's say 10 and so on, something, then you actually send a request to an HTTP server. Okay, there is an HTTP processor also there. For now, it may or may not be running. Okay, you can just put a processor there. You just have to connect it, but it will give you an idea like why what we are doing. Or you can even do an email. Okay, for that matter. The idea is that I am want to do monitoring. What I want to explain here is how you can use Nifi for monitoring. What we are monitoring, we are monitoring a particular flow, a particular data flow that we have created, and we are monitoring a specific processor, which is a critical processor's logs in real time, because we are doing a tell here. Continuously we are processing from tell we are processing logs. And if I see if error threshold in real world, but in for our use case we can say even info, because a lot of info would be there, error threshold reaches a particular point, I see, yes, it's a cause of alarm, I need to take some actions, I need to see what is the issue. Is the problem statement clear, all of you? Then you can either send an email, or you can put some HTTP server call, something. Maybe you can even send an SMS through HTTP call. Okay, there are some SMS service provider. Guys, is the problem clear? Do you understand the business significance also? What we are talking about? Okay, so what you do is tell file. Tell file is a processor out in the box. What it does is it actually tells. If you see the Unix utility, if you tell a file, means you are actually, what exactly tell does? Can somebody tell me what tell does? Telling a file means you are continuously getting in the end of the file. You're continuously reading the end of the file. Yeah, last 10 lines. That's right. So last few lines, last 10 lines, and you can configure, of course, but by default it's 10. So you are continuously reading the last couple of lines, last 10 lines of the file. So in this case, the file that we created, status check. Okay, and it will keep streaming that data. Guys, we're talking in real terms now. We're talking about real-time streaming. It will continuously read that data from that file and will keep taking in this data and sending it to this data flow. So if you see here, on the leftmost side, I have tail file processor. It will keep on reading the last couple of lines, last 10 lines, and send it to split text. Split text, guys, if you see, okay, this particular processor, please go to your flow and just do split text. Okay, let me just show you here. So this is split text I have. Okay, look at this. So this is my processor. I have stopped it, of course, at the moment. Now if you go here in the properties, look at this, what I'm saying here. I'm saying that I want to split each and every line. So line split count, and whenever you are in doubt, always refer this definition that Nifi provides you. The number of lines that will be added to each split file, excluding header lines. What does it mean? That I want to take into consideration each and every line which is being pushed from that particular upstream processor, which is my tail file processor. So every single line in that particular file of course, the tail, like I'm reading out, 10 files, 10 lines at a time. So every single line I want to split. Every single line will be processed. You got my point, right? So each and every line, it is going through this particular processor, which is your split file processor. So essentially means I want to explore every single line which is coming in my way. After that, I'm doing route on content. What does that mean? Is that clear so far? Tel file gives you the last 10 lines continuously reading in streaming form. It is
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in Big Data Analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job. Now let's continue with the session.
so continuously you will getting in data because logging is happening continuously. You are getting in data, passing into split text. Split text is reading every single record, every single line, and then passing it on to route on attribute. Okay. Sorry, route on content. Here, not attribute. We are playing around with the content of the file. So route on content is another processor, out of the box processor that we have here. Okay. Now what happens is you got every single line. Now here you are playing around with your logic. What are you saying is I'm checking out whether any specific match happens or not. Okay, I think let me just take you to that file. Then probably, so let's say I'm just doing a check for this file. Any file you can take up. Let's say this file. Okay, your main file. Okay, now these are the logs we're talking about. Okay, these are the real logs. Okay, which are happening in your app log file. It could be any file which we created also. I mean, I'm just giving an example. You see here, every single record like this, I'll be getting in my split text. So this is what split text plays around. Now, this particular record will be separated and passed on to my route on content processor. All right. For example, like this record, let's say, gets processed through, or maybe let's say any record you can take it. It's completely fine, right? So let's say I take this record, okay, or I take this record, right ahead local service or something, right? Something is there in that record. Some context is there. Some meaning is there. Some text is there, right? So what I'm going to do is in my route on content, I'm actually looking out for this. I'm saying that my content must contain match. I am looking out for a specific string, a specific substring, a specific text in that particular record. Every single record which I'm getting, I'm looking out for a specific text. Now, what is that text? Okay, this is where you are creating attributes. Okay, how do you create attribute? Like you go here, okay, and put it here, property name. So I'm saying, let's say if I'm just giving the example. Hypothetically, I'll explain you how it can help. Let's say my line contains Kafka producer, this particular text. Then the match should be this way. Okay, this is how, if you see your expression language, so for matching a particular text, this is how you have to provide. So braces, you are providing it in the braces. Okay, so what I'm saying is Kafka producer. So I'm matching that. I am putting up a property name and I'm saying what I'm trying to match there, Kafka producer. So if my record has Kafka producer, similarly if my record has Nifi web server, okay, so similarly if my record has time driven process, okay, because here if you see the file, I'm just trying to give you an example here. So for example, in this file, let's say I can check right ahead local. I can check Nifi web server. I have put in there already, right? So based on what you want to actually monitor, right? Typical what business use case would be, you want to see the error. Okay, so you want to probably put the error there and say that whenever there is an error, I want to be informed. I want to be aware of error logging there. So if there are so many errors happening there, then there is something wrong for sure. So it requires an attention. All right, guys. So this is how actually you play around with it. So I have created, let's say here, 3 attributes. I have given some text. Okay, I have some hypothetical text here. Let's say now what is happening is, please understand, I'm getting in data from my tel file processor, last 10 lines continuously streaming, splitting it every single record. Every single record is being judged against a specific content. So, for example, Nifi web server or Kafka logging or whatever. It could be in real world error warning. Okay. Now, once you have done that, then comes the real fun. Once you have done that, what you do now is you actually pass this on to Kafka. Okay, because we are talking about real time, and this was one of the use cases that you guys were asking about, that how would you make a Kafka integration there, and how would you do the real time use cases using Nifi. So please understand, we are talking in real terms. Continuously data is getting streamed, passing it through the split text route and content. You know what it does now. So if you go to your route and content, right, if I expand it, you will see here I will have these different relationship available there. Okay, the relationships are that Kafka producer, Nifi web server, time-driven process. These are the three attributes that I've created. So it will ask for how do you want to route the data based on these different relationships. And then finally, unmeshed. Okay, if it is unmeshed, then what should happen? So what does it mean? That all the records that you will have, they will either have these three different contents, or it could be possible that none of them matches. That will be unmatched case. So now you have got four different possibilities out there. Is that clear, guys? So what I'm doing here is understand out of these four possibilities, if it is unmatched, I am just terminating it here. So if so what does it mean, guys? Can somebody tell me in business sense? So can somebody tell me in business sense what does it mean? I am saying I have got four controls here. Three controls are the attributes that I have put in there. The fourth is unmatched, because some of the records will be unmatched. They will not have any one of these different contents that were mentioned. Kafka producer, Nifi web server, timer driven process, but there would be records which don't have any one of them. That will be unmatched report. What does that mean? That I'm not interested in that report. What I'm interested in, only business senses, I'm not interested in those reports, because what I'm doing is, if you see my flow, I am only interested in later on. I am only interested in Kafka producer, Nifi web server, or timer driven process. If the record is unmatched, I am terminating it here and here itself. Okay, I'm not taking it further because that is of no use. I'm not interested in that. I am interested in either of these contents, or maybe I can say info or error or warning. Okay, let's put it that way. I'm only interested, or maybe it could be only one. I'm only interested if there is an error. That's it. Rest of the things I will terminate here. Got it, all of you? Once you have done that, you are passing it through different Kafka publishers. So we are talking about real time. So what I'm saying here is, I'm talking about publish Kafka as processor. Look at this. This is your publish Kafka processor. So please understand what is happening. This is very crucial, guys. Very important processor we're talking about, and this is your business use case also. Okay, please keep a note of that. It's a very important one. Is there any limit on how many attributes we can check in route on any call? No, as such, practically no limit. It all depends on how scalable your deployment is. Okay, you can have as many as you want. Yeah, so it's all about how much scaling you can do. Okay, that's it. So we'll see those clustering, etc. Okay, now what is happening is, please understand Kafka producer. What we are doing is, so I am passing in one of them, like you see here. Let me just go back and show you again. So what I'm doing is, I'm passing Kafka. If my record has Kafka producer, I'm passing into this guy, the first published Kafka. If it is Nifi web server, I'm passing it to another processor. If it is timer driven process, I'm passing it to another processor, and so on. Okay, got it? So what does that mean? That I have business use case where I want to process these different records differently. Okay, so for example, if it is simple info, let's say, then everything is hunky dory. Okay, everything is good. I'll simply put it into let's say Kafka producer, and then maybe HDFS. Okay, later on I'll put it into, I'll just put my data into HDFS. Everything is fine now, right? Or maybe I'll discard it. I mean, doesn't matter, because this is the info part. So if in first place info, you won't even take it further. You will terminate it then and there, like you have terminated unmatched. But if it is error, what I want to do, I want to do further analysis. I want to see what is exactly happening, what is the problem exactly, and for that I can do event processing further on. I can probably maybe end of day I want to see, or maybe every half an hour I want to analyze. So what I can have is, I can put the data into HDFS or maybe S3, Amazon S3, okay, somewhere, and then I can do a recurring batch job every half an hour. Those reports are getting analyzed, and then that's unstructured data processing, of course, and then we are figuring out like what exactly is happening, what exactly is the reason for so many errors let's say happening in half an hour. As a business, I would say that, let's say 10 errors, if I'm getting half an hour, that's the usual stuff. I won't bother about that. But if it is happening really, really quick, I'm getting hundreds and thousands of errors every half an hour. No, then there seems to be something wrong. It is quite unusual. I need to have some sort of actions around it. I can do that. So that's what we're talking about. So what I can do is I can go through publish Kafka, then there will be a consume Kafka later on. We can put data into HDFS, and from there we can have further processing and then send some email or SMS or whatever you want to do. Okay. This is how this complete business process looks like. But let me take you to this one by one. Now, publish Kafka, let's say I'm taking up, as I told you, these three different data points go to different Kafka publishers. Now, this publish Kafka is a processor which you can get in from here, right? Here, if you see, publish Kafka. Okay, so we're talking about this guy. Okay, this is Kafka 2.0. Okay, so you have to be very careful about it, that you use the right Kafka versioning here. Okay, because it depends on which broker you are using. So if you are on less than 2.0, then you should use 1.0 plus. If you are using broker 2.0 plus, then you should be using Kafka producer also accordingly. Okay, and then guys, Kafka is real-time messaging service, distributed service. You know all about it. After that, sky's the limit. Once you got your data in Kafka, sky's the limit. You can take it further. You can have consumers. You can take business decisions accordingly, as I just discussed about. Okay. Now, do you understand now, like how exactly we can make use of NiFi attributes and NiFi processing capabilities and take care of our business use case, right? All fine. Tail file processor, guys. So tail file processor is this. Like I am saying, this file. Okay. So the properties in this is I want to actually do the logging. I want to do this NiFi app log. This particular file in my logging directory. This file I want to monitor. So I want to tell this file. I want to continuously stream last 10 reports from this file. As and when the data is coming in, continuously data will keep going in there. I'll show you that quickly. Okay, and then so you can have single file, you can have multiple files. If they are multiple files, then you have to provide a regex expression. Okay, what kind of difference? Because there are so many files in a particular directory, then which particular file you want to tell? What is the pattern of those files? So that you can do. Since we are doing the single file, so I'm giving the exact path. Initial start position, beginning file, okay, and so on. Rest everything I've left default as is. Cool. All right. So not an issue. Please do understand for now. So let me just show you this, happening. For that, what I've done is I've installed Kafka. I've not used Docker. I can do Docker also. Okay. So if I just show you this, so you can install Docker, and once you have installed Docker, you can have only this command running, and your Kafka will be up and running. Okay. You can do this. Okay. So if you are aware of this Docker, you would know what does it mean, that this particular command would actually start zookeeper at 2181. It will start web server at 30. It will start schema registry at 8081 port. It will start Kafka Connect also at 8083. It will start brokers at 9092. And this is where it will say my advertise host, means this is my broker address, right? And so on and so forth. And this is your image we're talking about. Okay, we are talking about this Kafka image. Okay, so what you see, this is the power of, I'll put this command here. This is the power of Docker. Okay, and a single command, if you've got your Docker up and running, okay, and a single command, you can have everything related to Kafka infrastructure up and running. That's the power of Docker. So as I told you, right, Zookeeper will be up and running, Kafka will be up and running, brokers means, and then Kafka Connect, registry, etc. If you want. That's the power of Docker, and that is why I'm showing you this, because I want you to motivate enough to learn Docker, guys. Not only for this training, I think even for your career perspective, we are moving towards microservices. Docker plays a lot of role there. Okay, so please do learn Docker, and since you are having an opportunity here, please grab this opportunity with both your hands. And then once you've done this, right, that's it. Kafka is up and running, and you can play around with it. I assume that you have Docker up running. If you have not installed Docker, then it won't work for you. Okay. Now, once you have done that, after that, it's like creating topic, etc., etc. Okay. So what I'm going to show you now is I have done stand-alone installation as well, not through Docker. I can do through Docker also, but I do know that most of you, as per my discussion, majority of you, if I can put it this way, don't have Docker knowledge, have not installed Docker as well, and probably some sort of understanding you would require before I start using Docker commands, right? So it will be a different discussions altogether if I do Docker discussions here. So that would probably take some time, right? So especially for the Kafka purpose, what I have done is I have done the standalone installation. Okay. Now, how you do that? This is where it is. You can follow this link. Okay. Those who are not comfortable with the with Docker and want to actually have Kafka installed up and running on their local system, please follow on this particular link. Okay, it's just a 10 minutes job, not more than that. You can have Docker does it very quickly, but if you want to do it without Docker on your own, you can do using this particular link. It's just a matter of 9 to 10 minutes, not more. Okay, so I have done a local installation, means not through the Docker because as I told you already, right? So I'll show you my Kafka is up and running already. Okay, if you go through this, guys, can you have a look at this link? Okay, it gives you step by step everything. Yeah, I assume Java is already there because you are running Nifi. You just have to do what? Let me just show you that link quickly. So whether you are on Linux or you are on Windows, you can follow that through. So this shows you how you can get your Kafka up and running. So Java, JDK, I don't think so you require it because it's already done. Zookeeper installation. Zookeeper is the distributed coordination service. So Zookeeper you have to have, right? So what you have to first do is, guys, go and install Zookeeper. So take it from here, Zookeeper, take it Kafka from here. So these two downloads you have to do. And please make sure that you take the latest ones. Okay, try to take the latest one, both of them, whatever is available. After that, this is a Zookeeper installation part. Quickly, you can have your Zookeeper up and running. Okay, just follow these steps through, and it is showing you how you can ensure that Zookeeper is properly installed. Then you have to set up your Kafka. Okay, so these are your installation steps for setting up Kafka also. Okay, you should be able to do. You should be able to do it in couple of minutes, just 10 minutes, not more than that. Once you have done that, you have to start Kafka. Okay, and you have to create topics. All these commands, anyways, I'll share with you. Okay, producers, consumers, all those things you can do. Because once you have got your Kafka up and running, what you have to do is you have to create topics there. Then there will be some publishers who will be publishing data. So those who are completely new, let me take quick refresher, guys. I'll be very, very quick. Okay, so that because Kafka is very important to understand the real-time part. A lot of use cases are there around Kafka in Apache Nifi. Very quickly, very, very quickly, I'll take 2-3 minutes discussions around Kafka. So assuming you have got Kafka installed using that link. Okay, what exactly we are trying to do here is that I have got my Kafka up and running. So this is my Kafka broker. Okay, this is my broker. Okay, Kafka brokers. Now, in on this broker, you have to create topics. Topics are nothing but they are actually logically isolated storage units on Kafka. This is where your data will get stored. Okay, so brokers are nothing JVM processes. Here we will have topic. Topics means the logically isolated storage units on Kafka. So your data actually for different purposes you will put on different topics. Okay, so for example, in this case which I was showing you, my weblog server, data will go to, let's say, one topic. Okay, the Apache Nifi server related data will go to another topic. Then the final, there was one more use case that will go to another topic. So we are actually logically separating this data, right? Data on Kafka. So we will have different topics for that. Now, what is happening is that that publish Kafka processor that we are using, right? That publish Kafka processor, what essentially it is doing is getting connected to my Kafka, means my broker, okay, and then sending data to either this topic or this topic or this topic based on the logic that I did show you there. Because we are doing different routing kind of stuff, right? If contains this, then go there. If contains this, go there. If contains this, go there. So what we are doing essentially is I'm sending it to one Kafka publisher if it is having one particular type of data. on another Kafka publisher or another Kafka publisher. You got my point, right? Based on what kind of data you get, data gets into different topics. Okay, and then later on from here, once the data is available on topics, we can have Kafka consumers also, which is missing there at the moment, but I'll take it up later on. Kafka consumer. So if you see, there are processors there. Okay, the Kafka consumers I can use. There is a processor Kafka consumer also, like you have Kafka publisher, which will actually pick up data from this topic, this topic, this topic, and then further on you can do business decision making, whatever you want to do it. Whether you want to put the data into HDFS, whether you want to do some sort of complex event processing, anything that you want to do, you can do that. So we're getting in data real time from various sources, using Kafka publishers, putting data into topics, using Kafka consumers, getting in data from there, and then taking it further. Whether you are putting in file, whether you are putting in HDFS, S3, or you are doing some sort of other processing, it's all up to you. Is that clear, guys? Very quick. You understand the basics of Kafka now? Very, very hot technology, Kafka. Okay, no problem. All right. So now let me quickly walk you through a tool. Now, guys, understand here I'm not using Kafka. If now, guys, you see what I'm doing here is I'm stopping it at the Kafka level, publish Kafka level, producer level. Okay, but I am not doing the consumer part. We can add and we will add later on the consumer part. But as of now, my job is to get the real-time data, do some sort of processing, some sort of text processing, routing on the text type, and then put it into different topics out there. Okay, now if I now you do understand topics, etc., let me take you to publish Kafka one. Okay, again, I'm saying first publish Kafka. Okay, first Kafka producer we're talking about. Look at this, guys. I'm saying that the data. Okay, look at this. I'm saying Kafka producer. If the content has Kafka producer, then I want to put data where in this topic, Nifi topic. Please understand. If my data is does have Kafka producer, then it gets into this topic. If my data has Nifi web server, it gets into this topic, Nifi topic 1. I mean, it doesn't make sense, but you put the topic name there, provided you have got topic there. I'll show you. Just hold on. Similarly, I'm putting into another topic. Okay, some topic here. So my different type of data gets into different topics, and then you can actually have consumers, Kafka consumers there, which will read these topics and do further processing as we discussed. Okay, makes sense, guys? All of you do understand it completely? Now, how do you create topics is the question now. Okay, okay, perfect. Now, so you are clear what exactly we are trying to do here. Here, guys, if you see, so I have told you about the topics. One thing that I have done here is that if it is a success, look at this. If it is a success, I'm automatically terminating it. And if it is a failure on this processor, if I'm not able to publish, what I'm doing is I'm continuously looping through. The failure part is continuously looping through. Understand here. So what does it mean? That Kafka will keep trying out, putting data into publisher. Okay. So if there is any record which could not get into Kafka publisher, it will keep on trying. It will keep on trying. For the failure, there is a loop. I hope it's clear. Any questions? Do you understand the real-time part? We will build complex data flow from here. Okay, perfect. So since we have created these topics, as if you see the topics that I have, or maybe let me create a new topics just for your interest, and then just show you. Just show it to you. Before I do that, there's a tool which I've installed. Now, this is a very simple tool for Kafka monitoring, Kafka tools. Okay, again, just go to Google, say Kafka tools, download it. That's it. Very simple it is. Okay, and what it helps you do is it helps you monitor Kafka. So, for example, you see here on my cluster, if I just go to my cluster, this is my broker, and so many topics are already created. Look at this, couple of topics I've created here. So, Nifi topic, which I showed you already, Nifi topic error, Nifi topic warn, and then this Nifi error handling or something. Some topics are already there, pre-existing. Okay, you can just go to this particular topic that you want, just say this green button, just click on this, and then if you want to see the data, look at this. It will give you this data also. Okay, look at this. This is the data which is coming. The real time you can see the data. Look at this. So if you just expand it here, okay, it will tell you like what are those reports. Like you see here, you can go to any topic for that matter. Okay, like you see here, you got there, guys. Time-driven process. This time-driven process we had put it in the flow. You remember all these records which I see here, right? They are time-driven process, time-driven process. They contain this, right? Exactly the same thing I had in my flow. Look at this, time-driven process. Got it, guys? This is time-driven process. So that is the check I was doing. So this gets into this topic. Similarly, this one, Nifi web server. So let's go to that topic. Okay. So let me go here and look at this Nifi web server. So all the records which has got this Nifi web server are here. Does it make sense? All of you, do you understand it? What is happening? We are actually segregating the data based on what this data has. Is that clear, guys? So if you want me to run it, I can run it very quickly for you. So let me just take it, go here. And how many number of records you have, all of these things you can see here. Okay. For example, if you go to properties, do a refresh, 2054 records. If you go to error, refresh 1568 in this topic would have more because there are so many records related to the first string 4516. Okay, so it will give you the current records. How many records are there in these topics? Now you can quickly run it here. Okay, and anyways, I've got that file available there. The moment I'll say start, it will start executing it, right? And I'll start getting in data there. Do you now understand how it will happen? Okay, let me start it. Look at it. Now it has queued. So many records have already come in there. Okay, so the back pressure has started playing. Now it has taken data. Look at this, guys. It has turned green. The data has been picked up. Okay, look at this. Publish Kafka has got data. This guy has also got data. This topic has also got data based on what exactly is there in your file. Now let me stop it, and then go here. Right, look at this. Numbers changed because I've got some records here. Let me go here. Numbers change. I've got some records here. Say refresh. Numbers change. I've got some records here. Guys, do you see it, all of you? And this will happen continuously. I stopped it because I just wanted to, and you will continuously get this data, and then this data will get continuously processed, right? And then you will do continuous processing. So real time it is happening, and you know how end-to-end things are working. You can play around with it always, right? You can always do that. Is that clear now, guys, all of you? So we'll get any questions? Back pressure. So here you could see this, but just to give you an idea, what will happen is that a lot of data will keep coming in, right? So if you are running on a cluster and a lot of data is getting processed, right? Then what will happen is there will be a lot of logs, lot of processing. So a lot of logs. Then you are passing in through. So these are my queues here. These are my connections here, right? So what will happen is here the back pressure will be enabled. So for example, here the right practice would be that I actually do a lot of, because I'm expecting a lot of data on this queue, isn't it? After that, it will get segregated. So I'll put more back pressure configuration here in this and this, because every single record will get through here, right? So what I'll do is I'll put a lot of back pressure here, less back pressure here. This is how you will actually control it. So not 10,000. I'll, based on how what kind of data I'm expecting, I'll put more. Even size will also be increased in this particular connectors. And anyways, back pressure part we are discussing with hands-on shortly. Perfect, guys. All right. So I hope you would have Kafka up and running. Everything has gone into the failure here, right? Because everything is getting into either one of these processors, right? But if it gets into the failure, you would still have some records in the failure, and Kafka will keep trying out to get the data into your publisher. Okay. So with that, let's get through quickly. So now you understand the real time part. So that's cool. Now failure handling. Okay. Now as we discussed already, the relationships, right? So we have got success relationships, we have got failure relationships, and if you create a few more attributes, then you will get some unmatched relationships as well. Like we saw in the earlier case, there were a few records which were unmatched. Okay, maybe the use case could be you won't get any matching. Then how would you handle these different relationships? Okay, and then if there are any failures, how would you handle them? So the best practice is that you have to handle the failure scenario. The failure scenario, like in this case, I just gave you an example. If I'm not able to get the data into Kafka publisher at the first instance, what would happen in how I'm handling failure in that case? I'm doing a loop back. Okay, I'm giving an opportunity again and again, unless it is picked up by Kafka publisher. I want it to be looped back. Okay, I can do that. Okay, this is one way of doing it, but there are multiple ways you can handle failures. But let's understand a bit why failures happen, and then let's get into hands. Now, when writing a processor, writing to a processor should be, there are several different unexpected cases that can happen. So it's important that processor developers understand the mechanics of how the Nifi framework behaves if processors don't handle errors themselves. Okay, how do you handle them? What kind of different techniques you can apply? So when a processor is not able to process a flow file without errors, for example, could be an authentication error, could be a connection problem, could be a data problem, whatever it can be, right? Then it gets into a failure relationship. We saw that, right? There would be success and there would be failure. Some of the pretty common scenarios is like network issues, especially in Kafka cases. Typically that's the reason I have this flow back. Kafka cases typically, it happens that if there is a slight network disruption, because I'm getting data continuously, what will happen is there would be some failures. I won't be able to put data into publishers. So the best practice, especially in the Kafka terms, is that you try to put a loop back there, so that more and more chances you are providing to those records or those flow files to be.
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in big data analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job. Now let's continue with the session.
Processed or to be available to Kafka produce. Okay. Similarly, based on different scenarios, we would take care of different use cases. So, for example, let's say, like in Kafka case only, let's say, do I need to do infinite loop, or should I probably try for some time? Maybe let's say a couple of times, maybe let's say 3 times, 5 times. And if it is not happening, even after that, I'll say, okay, then this particular record I'm not able to index. What does it mean, guys? If I am trying out, let's say 4 times, 5 times, right, and after that, even then I'm not able to get the data in publisher, what does that mean? That it doesn't seem to be a network problem. Ideally, if you see, right, if it is a temporary problem, a slight network problem, it should have been taken up by the processor after 5 attempts or maybe 10 attempts. But even after that, it is not happening, then it doesn't seem to be a network temporary issue. It seems to be some other issue, maybe related to, like, disk is full, because Kafka stores data in the topics, and topics are stored on disk. So there is possibility that disk is full. In that case, infinite times you try, guys, it will never ever get into Kafka producer, right? You won't be able to write in the topic. So in that case, what you do is the best case scenario, right? Like even in this case, it should be that you try out for a couple of times, 4 times, 5 times. Even then, if you are not able to put data into Kafka, leave it and put it into error storage. Maybe some directory you put the data into and say that, this data could not be getting, I could not write it to Kafka topic. Seems to be some issue. Let's put it into some error handling, so some sort of directory, etc. Guys, you can't miss the data. Please understand. You should account for each and every record that you've got. Okay, so whether the data is getting into either of these topics, or if it is not possible, put it into some directory, or HDFS, S3 somewhere, so that you keep an account of whatever you are getting. Okay. Some of the pretty common failure scenarios, network issues could be there. Okay, you can have your disk full, you can have your flow file issues, data issues, right? There could be different sort of errors, but the idea is that, if, because we are playing around on networks, right, there's a lot of network issues also do happen, especially in real-time scenarios. But the important thing is that you should be able to handle those scenarios. You should be accounting for each one of these failures. Okay, you should think about the kind of failures that you may have, and if there are failures happening, then handle them properly, appropriately. Okay, like you see this scenario. Okay, so guys, if you can just try this out. Okay, so I have given you enough information already, and I'm explicitly putting in the processor name also. Now, this particular problem is, and you don't have to do, you don't have to run it. Okay, the only thing, because you don't have Kafka here, but you can of course do the connections out there, isn't it? That connections you can make, at least the flow, the data flow you can make, right? Can you try this out? This is a real world problem. Okay, you generate some data, use generate file processor, then use retry flow file. That's another process. If you search, what it does is it will try sending data to Kafka, let's say 3 times. Okay, and if it will retries fail after 3 times also, then you have to handle this data. It will not get into Kafka topic. You put it into, let's say, put file or maybe put HDFS processor for further handling. So can you try to create this data flow? Do you understand this problem, guys? You can use publish Kafka 2.0. I have given you retry flow file also. What exactly it does? I have given you that information also. Go to its documentation. Right? Take this processor, right click, get the information about it. See which particular property would be required here. Is it already available? How do I make the connection? Think about it. Can you take it up, guys? Or or should I show you the solution? You want to give it a try? Please do it quickly. You don't have to run it. Just create a data flow because you don't have Kafka. Otherwise, you could have run it also. So when you have got Kafka up and running, maybe during today, your day, please give it a try later on also. But at least have the data flow in place. So take 5 minutes and please do it. So relationships you have at let's say retry flow file processor level. How many relationships you see? How many options are there? How many relationships in the sense? How many connections you can make from there? You understand what I'm saying, right? They're like success, failure, etc. So what are they? 3. Very good, Jerome. What are they? Can you name them? Can you please tell me what are they? Okay, failure. Very good. Retry exceeded. Absolutely. And finally, retry. Absolutely. Retry exceeded, failure. Very good. Absolutely. Now what you do? So if it is retry, where it goes? The connection goes where? What is the downstream processor if it is retry? It is Kafka publisher. Very good. Absolutely. And if it is retry exceeded, where should it go? Put file, okay, or HDFS. Where here we are talking about put file or HDFS. Okay. So there is no log attribute which is coming into picture. Okay, log attribute, no, it's not there, right? I have explicitly even put these processors names. So we are not doing log attribute here. Log attribute is not required here. Guys, do you understand it, right? What we are doing is we are saying that generate file, do a retry flow, which actually keeps a tab on how many number of times you want to retry. If it is a retry, then it gets to Kafka because it will keep trying, for 3 times. But if it is retry exceeded, right? That's what I was asking. Where should it go? Because I put in here that if it is more than 3 times, send it to either put file or HDFS. That's right. And how about failure? How about failures? Because you said there are 3 controls, there are 3 options. Failure, where should it go? I'm talking about FlowFile processor, retry FlowFile processor. There you have got 3 options, as you rightly pointed out. There are 3 relationships which you can have for this processor. One of them is retry. I understand it should go to Kafka. The other is retry exceeded, and you guys pointed out that should go to HDFS or put file. Very good. And now, how about failure? This is important. So can you think about it? What you should do if it fails at the retry flow file processor? Even what should you do? I mean, think about it. These are the real situations we are getting in there. My business use case was simple. I want to try 3 times. If it gets okay, gets into Kafka, fine. If not, then what? No, auto terminating, as I told you guys, please understand. I was telling you that every single record I should be accounting for. If you do auto terminating, what is happening is you are losing that record, isn't it? You're losing that record because you are not taking it to next level. So what is happening is either you are getting into Kafka, okay, if it is exceeding more than 3 times, you are putting into put file. But what if it is failure? You have to still account for it. You should put it in the put file or HDFS. Absolutely, you should still put it in the put file or HDFS. It may be a different processor, that's a different thing. Or in this business use case, ideally in the retry exceeded and failure cases, it should get into put file or because we want to account for every single record which is coming to us, right? Guys, is that clear, all of you? And please, once you have Kafka up and running, please try it out, okay? Please give it a shot. Okay, let me show you if I think I have it, or maybe I don't. Let me check it out, or maybe I'll create it very quickly if I don't have it. So this is how it should, not visible. Okay, 1 second. Oh, I stopped sharing. You will see it shortly. You can see now. Okay, so we are using the generate file. It actually generates some sort of random data. Okay, so let me show you that generate file. This is for generating random data, as I told you. So Look at the properties. What I'm doing is file size is 100 bytes. Okay, some sort of random, not able to figure out. You won't be able to figure out what exactly it has generated. Some sort of garbage it will generate, but that's fine. Batch size, I'm saying 10. You can put at 1 also. When I say 10 batch size, you can always refer here that it will actually take up 10 files at a time. It can take up 10 files at a time and then take it to the further level. So you can put 1, 10, anything. Okay, for that matter, because we are just doing understanding point of views. We are actually discussing about it. Now, if you see, please understand that what I'm doing here is so this is my generate file. Okay, it will generate some random file. Okay, then what I'm doing is I'm sending it to this. Okay, Kafka. Now, if it fails there, then what I'm doing is I'm trying a retry. Okay, the queue, if you see this queue, what I'm trying to do, guys, I put the name also, and this is a good practice, guys. Always put a name for your component, okay, any data flow, so that you can figure out what it is. Okay, the moment somebody looks at your template, does figure out. You can always use comments also in the queue. You don't have comment section, but in the processes you have. So that's a good practice. Good practice is always put meaningful names, always put comments wherever possible. Okay, so these are the good practices. So what I'm doing is I'm putting in this data into Kafka, and the failure, because earlier we were auto looping this failure, but if it is a failure, I'm sending it to retry flow processor. Okay, what retry flow processor does is here retry attribute by default it comes in, and maximum retries I'm saying 3 here. That's why I was saying that you don't have to do anything. You just go and check the uses here, what it does, and what kind of attributes you already have. Okay, so it actually tries for 3 times now, and here that's what I was asking, how many different relationships you have. So there is a failure, there is retry exceeded, there is retry. Okay, and that's what I'm saying. So the retry, I'm taking it to Kafka again because I want to try 3 times. Okay, again and again. But if it doesn't succeed even after 3 times, okay, it will get into these failure and retries exceeded. Okay, and for these two, I want to put the data into put file. If it is failing after even 3 times, or there is a failure even after retry is exceeded, then what I'm saying is I want to put it into a put file. Got it, guys? Here, scheduling, you see, I put it in just 10 seconds. And now you see, if I put it at 0 second, let's say, scheduling. Okay, guys, if I put scheduling is 0 second means I want to try it out again and again, continuously, as fast as possible. Time driven, the scheduling is. Now look at the magic. Let me run it. And before I run it, the topic I'm looking at is Nifi error handling. So in my Kafka broker, Nifi error handling, this topic I'm talking about. So let's see how many records we've got. So I've got a lot of top records already there. So around 1.7 lakhs. Okay. Now see the magic. I'll just you understand first of all, is this flow? You understand it, right? You know how error handling is important and what decision making you should do. Perfect. Now I'll just run it for you. I'll say start, and now it will generate some files, right? And put data into Kafka. Now it started doing that. Look at this. My this back pressure 9,700 queued already, and 9,770 and 10,000. Now that's it. Now it will, right. It's getting in. Now Kafka has picked up data. See here, guys. From the queue, Kafka has picked up data. It is going on and going on. Let me stop it now. Okay. Let me go to my Kafka, this thing, this topic, and see a refresh. Look at this. How many reports I've got? 3.26 lakhs from 1.7. So quickly, real time, it has picked up data. So many records has come to Kafka. How many records have come to Kafka? Got it? Now here, nothing has come. You see, in the retry, there was, everything was success. After retry, everything was success. You are getting into Kafka. But if there is a network disruption, guys, you will get some of the records and put file also. Okay, there would be the use case, right? And now the back pressure part. Okay, so in this scenario, since it's now it has take up everything. You see, Kafka. This is what the messaging system is all about. It has taken up everything. So now the data is on Kafka topic. Understand, guys? The top there are so many records on Kafka topic which it has not been able to right. So now it has taken up data from the queue. Queue is empty, but the data is available on Kafka topic. Okay. So you have accounted for every single record which is getting generated, and it is available on Kafka topic. If you want to, take care of the back pressure part here, right? You can take care of, let's say, the scheduling. So I'm saying 10 seconds, let's say. Only every 10 seconds I want to get the data, not the moment it gets generated. Okay, so it will actually help me control the flow of the data. Now, if you try now, right, it's generating data. Okay, some sort of magic is happening. Now you just go here, refresh it. Okay, so data has started coming in. All right, guys. So this is how you can actually start playing around with Kafka. And is that clear, guys, all of you? So it's about how do you now back pressure if you want to handle. Anyways, so this is one way you can, you can ensure that the kind of data you are getting in is basically based on what kind of configuration you have put in your queue. So you can either increase it, depends on, or you can scale it, right? Scaling anyways we will see. So you should always be accounting for it. And then the best practice is you should always put the names, relevant names. So for example, in this case, retry flow file, put file, I can say here, my here the names can be changed here. Okay. So I can say the error handling or error sync. Usually, this is how you say error sync. So I'll say this is where my error data goes. Okay? This is random data generator. Rather than this, I will say this is random data generator, something of that. And even queues, you should say that what exactly this queue is meant for, whether it's for failure or retry or queuing, whatever, right? That's always a best practice. Perfect. So now you understand this bit of failure error handling. Okay, how to do that. Now, if you see the update processor, okay, so this guy, the update processor, if you see the definition, is a configuration, just open it up, okay, and go to the properties. Now you see what I have added up here. That's what we discussed. That file name is an attribute I am adding up. Now, please understand, file name is anyway coming from your flow file. But what I'm doing is I'm making a change. I'm actually overriding that file name because exact attribute is part of your core flow file. We discussed about it. So what I'm doing is I'm actually making, I'm overriding it. And what I'm doing is file name and I'm using prepend. So this is from the expression language. We'll discuss about expression language in details tomorrow. So prepend, and then what I'm saying is that I'm prepending the current timestamp. Prepending the current timestamp. Look at this. Only until minutes. I don't want to do seconds. Okay, there is a purpose to it. But I'm just doing up to that particular minute. So what would happen is every single file that is coming in through this particular data flow will get the timestamp up till minutes appended to it. Okay, so timestamp up to minutes and then that particular file name. This is how my file name would look like now. Clear? Okay, I'm adding up this extra. Now, after this, okay, what I'm doing is I am putting the data into a specific directory. So in this case, I put directory, let's say target directory. Okay, this we have seen already. Important thing which we have not seen, but I'm sure you would know is that look at the conflict resolution strategy. The conflict resolution strategy here is that if there is a conflict, and look at this, indicates what should happen when a file with the same name already exists in the output directory. Okay, that is a conflict resolution. So if already there is a file and I'm putting an extra file, what would happen? It says fail. Don't overwrite it. It will fail. Your processor would complain. It will not allow. Okay, and that is the reason why there would be a failure scenario in the put file scenario. Now understand, guys, what is happening is I'm getting in data through log attribute, right? Then update attribute, I'm changing the name of the file. I'm appending my timestamp up to minutes with my file name, right? Now if I write my same file again in get file within that minute, okay, within that minute, given minute, if I keep copying the same file name, what is happening? Can you imagine now? My file name would remain the same for that minute duration because my minute same minute it is the same minute I'm putting in the file in the get file processor. After update attribute, file name would be that timestamp file name, so it will be the same file. Now if you're trying to put in the same file in the put file processor, we have seen the conflict resolution strategy. It will not allow, it will fail, and that is the reason you'll get into error scenario. That is the reason you will get into error scenario, guys. So for simplicity's sake, initially what I'm doing is let me take care of, let me terminate both of these here. Okay, let me just remove this first. Okay, and I'll just terminate both success and failure here. Okay, let's see this way. So I'm putting in, what it will do is it will try to put in the file here, in the put file process. So both success and failure, I'm trying to terminate it here. But that's not the right practice. We will see that. Is that clear so far? Is this flow clear? And what are we trying to do? Oh, right? Now, guys, can you quickly do it? Can you also quickly do it, please? Perfect, guys. All right. Now, since you have done it, please run it. Okay. Please run it. So you start your data flow. Start it now. Wherever the get file is, just go there and put your file there. So you can take any file. Let's say I take any file. Let's say I take just any file for that matter. Just put it here. Okay. Got picked up. Now you go to your destination directory, which is target. This is, let me just remove everything. I think it will be confusing otherwise. So let's do it once again. Let one file available here, put it in the source, gets picked up. Okay, go to your target directory and look at it. So what it has done is it has appended the timestamp. Look at this timestamp. It has appended up to minutes and then the file name. Okay. Now, if you come to your flow and see it here, there are two files it has written in the put file, and both of them are written successfully. Perfect, guys. Both of them are written successfully. One I had already deleted, so I have one file in my put file. Got it? Now put one more file and take care of this bit that your name remains the same, because we are playing around with the same name. 3. It is still successful. Why, guys? Because we have exceeded the time limit, that is per minute. So if you go here, look at this, the minute had changed. So it has allowed, because the file name changes now, right? 8:45, 8:46, 8:45 a.m. here, right? Now, to produce the error, what should I do? To produce the error scenario, what should I do? I should put my files within the same minutes, okay? I should files within the same minutes. So within the same minute, I put the same file thrice. Now I'll go here. Okay, do a refresh. Look at this, guys. First of all, let's go to the target directory. I had put many times, right? But you see, 8:47, I have only one file. I should have got 4, 5, but no, it's not there. Why? Because conflict resolution strategy, the file name remains the same. It will not allow. It's not allowing. So only one file gets written here. And then I've got the error strategy. Now, what is happening here is, if you just go here, right, and check it out, it is saying that, let me put it here. It is saying that, because the file name remains the same, look at this, the file name remains the same, it is giving me the warning, it is not allowing me to write the file. Can all of you reproduce it, please? You understand what I'm saying? Yeah, you can go to bulletin board. Okay, just go here, bulletin board, and check it out. Go down. Look at this. It is giving you this issue. It is saying put file is complaining because routing to failure as configured because file with the same name already exists. This file with the same name already exists. If you go to your logs, also you will see this error. Just go to your logs and check it out. You will see the same error here because it's coming from logback.xml only, your bulletin. All of you understand it? Now, what is happening is, guys, I have actually handled the error scenario. How? I have handled the error scenario that both success and error terminate irrespective of whether you are getting a failure or not. But that's not the right practice. To handle the scenario, what you should do is you should put the success terminating there and the failure should be auto terminated so that you can have a failure strategy, what you want to do. Okay, one way of handling the failure is I'm doing it for failure. What I want to now see is that if there is a file which is coming with the same name, I should handle it differently. So it should come into my queue, right? Now it will come into queue because failure scenario is getting generated when we are having the same file, right? File with the same name. So next time when I'm putting the file, it should come to my failure scenario, my failure queue. You understand it? Okay. So for removing confusion, or you can keep it as is, that's okay. Now I'm putting in, let's say, the file again. Let me put 3, 4 times, 4 times, 5 times, I don't know, 5 times I put in. Right now you go to your target directory, you will see. So it should have, okay, this is a stop. Okay, I have to start it. Look at it, this, guys. Do you see here? I had put file 4 times. One time it has got written, but 3 file, if you can see it, right? This guy, if you see, right, in this queue I've got, so this queue I've got 3. Right? There are 3 objects out there. Why these objects are in the queue, guys? Can anyone answer? Why? And if you go to target directory, it's written once. You see, it has got written twice because the minutes were different, but the other files are queued up. Look at this. It is giving you this warning that you can't getting it routing to the failure because the same name, and it has getting there in your queue. There are three queues. There are three objects in the queue. Why they are in? Because they are same name. Yeah, you're right, Sanjay. Because they have got the same name. All of you are with me on this at the moment. Could you reproduce it? Right now, what you can do is, right, if you want to, let's say, just a hypothetical scenario, we just go and clear these files. Okay, let's say last two, because I'm sure in one of them is there, so I'm just deleting these files. I'll just delete these two files, do a refresh. Look at this, queue got empty. It has, because whatever the objects that you had in the queue, now you see here, since now my this 850, 851, two of those, because the time, actually the minute got changed in between, so two of them it has pushed in. All right, now still I have got one particular failure there, because one object is still waiting to be written into the directory because it is not the same name. Got my point, guys? So this is how you handle it, right? The scenarios, you can't directly terminate it. If there is a failure, you know what exactly is the business significance. Should I handle? So how should I handle it? Like in this case, let's say the business scenario is that you don't expect the same file name to be there. So for example, there is a customer who is putting in data for processing into some directory. The customer is saying every day or every hour, you will get a file in the directory. Okay, and you process this file using your knife file. Then let's say, now what I'm doing is, if I am putting this error scenario here, you have to handle the failure, because the business sense says that you can't expect the same name. There should be. If there is any, you should handle it. So, the moment it comes into this failure, it means this somehow the same file has been put in for processing again. That's not something I'm expecting. So I have to handle the scenario. I have to escalate it. I have to handle it, take care of it differently. I can't directly. So let's say if I would have terminated failure and success there, like I did earlier, I would not have known, right? Like what is the issue? Though it would not write it again, but at least you should be knowing it, right? That what exactly is the problem is, why failure is happening. Once you do it, you do the failure scenario, error handling, you would come to know that there is a file which is of same name, which has already been processed. We should handle it appropriately. So that logic that we have written is to generate the file with the same name. Okay. Now, so for example, another way to handle the error is that you can probably, no, I'm just telling you. So what you can do is, such is a scenario, I can just go here, okay, and change the configuration of my queue. Okay, and I can say, hey, if such is the scenario that you are getting a file which is of the same name, okay, what you can do is you can expire these such files. Okay, maybe 0 seconds means you will never expire. Let's say after 10 seconds, I want to expire if the file name is same. So you check it, file name is same, you expire it. Okay, just apply it. Okay, guys, what I'm saying now, just run your files there again. For now, let me empty this queue, and now, so the queue is empty, there is nothing. Now try that scenario again. Guys. Try it out. Try putting in files with the same name and see if your empty queue is working. Does it empty the queue? But please make this change, that you have to empty the queue. If there is a duplicacy, just put this configuration flow file expression 10 seconds. Just repeat the scenario. See if you are getting only one file written and the rest of the files with the same name are getting expired. I need to have stopped it. Look at this. I've got 4 in my queue. 0. Do you see that? It got expired. It waited for 10 seconds, and then since there was a duplicacy, it got expired. So if there is such business scenario wherein you always care about the first file that you get with this given name. Rest of the files, if with the same name, that's a wrong business scenario. That's an error. Okay, you are not supposed to handle that particular file. That file shouldn't be processed. Okay, it should be directly discarded. Let me put it this way. You can put this scenario there. You can handle error scenario like this. If there is a duplication there, just expire that file. Okay, I don't want this file at all. Okay, let the business handle it, why exactly it happened. But at the same time, you should know it. Okay, you should know it. So once this comes into your failure queue, it means failure connection. It means there was a duplication. Guys, could you all understand it? All of you? More importantly, do you understand error handling now? Why error handling is important? Some business scenarios, and also could you do it hands-on? Could you see it happening? All of you? Okay, hopefully this interactive sessions are really you're enjoying them. I hope so because I'm letting you also do some things rather than just doing me everything on me. I mean, not giving you enough time. So I at least one problem I'm trying to ensure that at least one problem you do during the class. Okay, perfect, guys. So error handling is very important. All right, with that, would like to say thank you so much, guys, for joining. Take care.
Just a quick info guys, if you want to make a career in big data, then Intellipaat provides an advanced certification in Big Data Analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job.